Hey, welcome to Draft Academy. My name is Mike. In this course, I'm going to be teaching you guys everything you need to know to get started in the C programming language. C is an awesome programming language, and it's actually one of the oldest programming languages around. In fact, a lot of modern programming languages are based off of C. So it's a really good idea if you want to get into C, or even if you're trying to get into something like C++, to learn the basics. And in this course, we're going to cover everything you need to know. I'm going to talk to you guys about installing a text editor and using the C compiler. And we're going to write some basic code. I'll talk to you guys about, what is a program and how do programs work and how does C read the instructions that you give it. And we're going to get into some more advanced stuff. We're going to look at things like if statements and loops. We're going to create different variables. We're going to talk about the different types of data that you can use in C. Then we're going to get more advanced. We're going to talk about things like structures and functions. We're going to talk about pointers. And basically, I'm just going to give you a full overview of all of the core concepts in C. So by the end of this course, you'll have a really good understanding and a really good foundation which you can build on. You can kind of go forward and learn some more. I'm really excited to be bringing you guys this basic course on C. I'm really excited for you guys to dive in and start using these tutorials. So feel free to click around through all the videos and hopefully you'll learn something awesome about C. In this tutorial, I'm going to talk to you guys about getting everything set up to start programming in C. Now, in order to program in C, we're actually going to need two things. The first thing we're going to need is an environment where we can write our C programs. Now, there's a bunch of these different environments. Essentially, all you need is just a text editor. So anything that can allow you to write text and then save that text in a specific file format is going to work. Although when we're working with C, a lot of times it can be useful to use a special environment called an IDE. An IDE stands for Integrated Development Environment. Basically, this is a special text editor which makes it a lot easier for us to write our C programs in. So I'm going to show you guys how to install an IDE called CodeBlocks. The second thing we need to write our C programs is going to be something called a C compiler. Now, C is a programming language, which means we can basically write out, instructions that we want to give to the computer. But eventually, for the computer to be able to execute those instructions, they have to be compiled, which basically means like translated or transformed into a language that the computer can understand. So we're going to basically download and install a special program that will do that for us. So let's get started. I am going to come over to my web browser, and I'm just going to go up to the Google search bar, and I'm going to search for a program called CodeBlocks. So just type in CodeBlocks C, and this link should come up. It's codeblocks.org. Now this is an integrated development environment. It's basically a text editor that will make it really easy for us to write our C programs. So I'm going to come down here into downloads, and there's a bunch of options here. One says download the binary release, download the source code. We want to click on download the binary release. This is going to be the easiest option. So if you're on Windows or Linux or Mac, you can install it from this page. So depending on the operating system that you're on, you want to click that. I'm on Windows, so I'm going to come down here to the Windows option. You'll see there's little options for us to download this stuff. So there's a bunch of options here. What we want to download is going to be this one right here. It says CodeBlocks. And then the version number, and then it says min-gw-setup. Basically what this is it's going to allow us to install CodeBlocks. So we're going to be able to install that IDE program, and we're also going to be able to install a C compiler. So remember, I said we needed those two programs, we needed those two things, and this is actually going to give us both of them on Windows. So I'm going to come over here and click on the link to download this from sourceforge.net, and you can see it's gone ahead and downloaded that. So now let's head over to our downloads folder, and I'm just going to double click on this setup program. So this should open up a window where we can set up the program, and let's just click through this. So I'm just going to click next. I'm going to agree to the license and basically just leave all the options as default, and you should be good to go. All right, when that's done installing, it's going to ask us to run CodeBlocks, so we can just go ahead and do that. And it's giving me this little window here. It says compilers auto detection. So you can just click on the one up here that's highlighted. It says GNU GCC compiler, and I'm just going to click set as default and click OK. And there you go. We now have CodeBlocks installed. So in the next few tutorials, we're going to be learning about setting up code blocks, writing our first C programs, and really just getting started with C. But for now, you have everything you need to get started. In this tutorial, I'm going to talk to you guys about getting everything set up to start programming in C on OS X. So if you're using a Mac, then this video will basically show you how to get everything set up. In order to start working with C, we're actually going to need two things. The first thing we're going to need is a text editor. And basically, we're going to use the text editor to write our C programs in. And you can use any text editor that you want to write C programs, but there's actually a special type of text editor, which is called an IDE, and it stands for Integrated Development Environment. And it's basically a special environment where we can go to write and run and manage our C programs. So that's the first thing. The second thing we're going to need is what's called a C compiler. Now, C is a programming language, so essentially what we're doing when we're using it is we're writing instructions for the computer. But in C, we're writing instructions that us humans can understand and work with, but in order for the computer to be able to carry them out, they have to be compiled or translated or transformed into a language that the computer can understand. And that's what the C compiler is going to do. It's going to take our C programs and essentially just translate them into a language that the computer can understand. So the first thing I'm going to do is show you guys how to install that compiler, and then we'll get a text editor. So what you want to do on your Mac is go over to the search bar, and you're just going to type in terminal and click enter, and a window that looks like this should pop up. Now the terminal is basically a program that allows us to interact with the computer using text commands. So we're actually going to need to use the terminal in order to do what we want to do. So first thing we want to do is check to see if you might already have a C compiler installed. So in certain circumstances, you might already have one. So you just want to type in cc-v and click enter. And you'll see over here, I have a C compiler installed. So I'm getting all of this information. You can see over here, it says like CLang, and it's giving me, a bunch of information. If you have that, then you have your C compiler installed and you're ready to go. But if you don't have that, I'm going to show you guys how to get it. So all you want to do is just type in xcode, select, and then space, hyphen, install. And click enter, and you'll see I'm getting an error here because I already have these command line tools installed. But if you don't already have them installed, and obviously then you wouldn't have that C compiler, then this is going to go off and install everything you need to get that C compiler working. So once you've run that xcode select command, just type in cc-v again, and you should be getting this version number. All right, so now that we have our C compiler installed, what we want to do is download an IDE. So we want to download a special text editor that we can use to write our C programs in. So I'm going to go over here to my web browser, and I'm up here at a website called codeblocks.org. And this is an IDE called CodeBlocks. It's one of the most popular free IDEs for programming in C. So we're just going to come down here to this downloads link, and there should be a few options here: download the binary release, download the source code. We're going to click download the binary release. And you'll see down here we have a bunch of options for Windows, Linux, and Mac. Click the Mac option. And if we come down here, you'll see that here is what we need to install CodeBlocks on Mac. So if you go over to the right side here, there's a link to SourceForge where we can download it. So just click that link and it should start downloading automatically. When that finishes downloading, let's head over to our downloads folder. And you'll see here we have our zip file. So I'm just going to double click on this, and this should give us CodeBlocks. Now all you want to do is just drag and drop CodeBlocks into your applications folder, and you're ready to go. So you have CodeBlocks installed and ready to start following along with this course and writing some awesome C programs. In this tutorial, I'm going to talk to you guys about getting our first C file set up. So we're going to load up a C file, and we're going to be able to get everything working and test out our program. So I'm going to open up my CodeBlocks program, and this is the IDE that I'm going to be using for the rest of this course. So I'm just going to double click on it and it should start opening. Once we have CodeBlocks open, you'll see over here there's a bunch of different options like create a new project, open an existing project. So we're actually going to want to create a new project. So whenever we're going to start writing some C files, we're going to want to create a new project in CodeBlocks. So you can either click this button right here, or you can go up to File, New, and Project. So either way, it's going to bring you to this window over here. And there's going to be a bunch of options here. Basically just, these are different types of like C projects that we could create. What we're going to be doing is creating a console application. This is like just a basic C project that you could run on your computer. That's exactly what we need. So click on console application and then click go. And I'm just going to click through this wizard. And you'll see over here it says C++ or C. Now C and C++ are both different programming languages. For this course, we're going to be working with C, so just highlight C and click Next. And we're going to give this a title. I'm just going to call mine Draft. And we're going to have to put this project inside of a folder. So I'm going to open this up, and I'm just going to put this on my desktop. So let's click OK, and click Next. And you can leave all of these options as the default, and we'll click Finish. So now what we should have is our first C project in code blocks. Now over here inside this little file explorer, you'll notice that Draft is right here. So that was the name of the project that I just created. Down here we have this source folder, so I'm going to click down, and you'll see we have this file here called main.c. And this is a file that got automatically created for us by code blocks. So I'm just going to right click and open it, and you'll see over here we have some default code. So up here, there's these little lines of code that say include. Down here, this says int main. So this is the program that we're given by default when we created our C project. And this is sort of like the simplest C program that you can write. Essentially what this program does is it prints out hello world onto the screen. So in order to run this program and test it and just to make sure that everything's working, I'm going to come up here and you'll see that there's this green play button over here, and it just says run when I hover over it. When I click this button, this file that we have open right here, main.c, is going to get run. So we're essentially telling code blocks to run this file and execute the program. So when I click the run button, we're getting this message. It says the project hasn't been built yet. Do you want to build it? Click yes. And now over here, this little window pops up. Basically, this is the command prompt. So whenever I run a C program, this little window is going to pop up. So if I was to exit out of this and run this program again, you'll see this window pops up again. And it basically just executes the program. And in the case of this program, all we're doing is we're printing out hello world onto the screen. That's actually what this instruction does over here. When we open up this command prompt, it's essentially just executing the program, and it's printing out whatever we told it to print out. So it's printing out hello world over here. And printing something out onto the screen is really easy, and that's one instruction that we can give to the computer. But as we go through this course, we're going to learn all sorts of instructions that we can use. But the purpose of this tutorial was just to get our C project set up and to test our main.c file. So as long as everything works here, then you're good to go, and now we can start really learning how to program in C. In this tutorial, I'm going to talk to you guys about the basics of writing a program in C. So if you've been following along with the course, up till this point, we've installed a text editor, we've installed a C compiler, and we set up our first C program and our first C project inside of code blocks. So now, essentially what we have is this file over here. This is that main.c file. I just kind of want to point out a couple things that are in here. First up here, we have these little instructions, which are just called include. And I'm not going to get too much into what those do in this tutorial. Later on in the course, we're going to talk about what these are actually doing and the specifics of, how they're helping our program. But for now, just know that in order for us to use our program, we're going to need to have these guys up there. Next thing we have is this little block of code called main. And it just has this name main. You can see there's an open and closed parentheses. And this is actually what's called a method. And don't worry too much about what methods are. We're gonna talk more about those in the future. But essentially a method is just like a container where we can put some of our code. And this method main is very important because this is the method that's gonna get executed when we run our program. So in C, we can actually write out a bunch of instructions for the computer, and then we can run our program. So we can tell the computer to execute those programs. And whenever the computer executes our C program, it's going to look inside of this main method. In other words, it's going to look inside of all the code inside of these open and closed curly brackets, and it's going to execute that code. So I have this instruction here. It's called printf. And basically this is just printing out some text onto the screen. When we run our program, it's going to come into this main method and it's going to execute all the instructions inside of here, namely this printf method. So if I was to run my program, then this is going to work. Now let's talk about actually running a program. Whenever we want to run a program that we write in C, we actually have to do two things. The first thing we have to do is what's called building a program or compiling a program. And basically what that does is it takes all of this C code and it translates it into a language that the computer is going to be able to understand and execute. So it's essentially taking this C program code, translating it into computer code, and then the computer can execute it and run our program. So the first thing we have to do is always build our C file. The second thing we have to do is run the file that gets built. So once we've built this program, we've compiled it down into code the computer can understand, we have to run it, basically tell the computer to execute that code. And in code blocks, it's actually really easy to do this. So we can come over here and this little gear icon will allow us to build our program. And then this play button will allow us to run our program. But a lot of times when you're programming, you're gonna want to build and run your code at the same time, right? You're just gonna wanna build it and run it just to see what happened, see how your program did. So we have this option over here called build and run. And this will both build your program and run it at the same time. So generally, as you're going through this course, you're gonna wanna be using this option, this build and run option. So when I click this, it'll essentially build my program, run it, and then it'll show up here on this little window. And this little window is basically a console window, you could call it. So a lot of people would refer to this as the console. And it'll just like output any information that we tell it to. So if we write a C program that doesn't output information, that doesn't print anything to the screen, then we wouldn't actually see this. But since we're using this printf command, that window is gonna pop up. So let's talk about how these programs actually get executed. Essentially, when we write a program, we have a set of instructions. So when I'm writing a C program, I'm basically writing out a set of instructions. Imagine you were writing like a recipe or something, right? A recipe is essentially just a set of instructions that when executed correctly will result in, cooking or baking something delicious, right? And that's basically what these C programs are. It's a set of instructions that when executed correctly will result in the computer doing something for us. And one of the cool things about computers is that we can program them to do anything. And C is one of the best languages to do that with. So let's look at this instruction over here. It's called printf. And like I said, this prints something out onto the screen. But you'll notice over here at the end, we have this semicolon. And this semicolon is actually really important. So whenever we write an instruction in C, we always want to end it off with a semicolon. That tells C that we're done with that instruction and we want to move on to the next one. So I could actually copy this instruction and I could paste it down here. And now we're basically going to be executing this instruction twice. So if I was to run and build my program, you'll see that we're not only printing it out once, but we're also printing it out twice. So when we run our program, the program comes down into this main method and it looks at all the instructions inside of it. So it starts with this first instruction, it executes it, right? So it prints out hello world onto the screen, and then it also prints out a new line. So this \n is like a new line character, and that'll move the text onto a new line. When it's done with this instruction, it moves on to the next instruction, and it'll execute that instruction. So as we go forward and we learn how to write in C, we're gonna learn more and more complex instructions. And we'll be able to use all those instructions in conjunction with each other to specify some seriously complex programs. But for now, this is really the only instruction that we know, which is printf. So why don't we use this printf instruction in order to draw out a little shape onto the screen. So I'm gonna show you guys how we can draw out like a little triangle onto the screen. I'm gonna take this printf and I'm actually just gonna get rid of hello world. And I'm gonna copy this a couple times. So I'm just gonna copy it and we'll paste it down here, maybe 4 times. And what I can do is I can specify instructions to the computer that will tell it to draw out a particular shape. So down here I could make like a / and over here we'll make another one, and I'll make another one, and I'll make another one. And you can see here I've drawn like a little diagonal line with these /. Now I'm gonna draw vertical bars going all the way down. So I'm gonna put one here, I'm gonna put one here, I'll put one here, and finally, why don't we draw some underscores and then we'll put one. So I'm basically drawing out a little triangle shape. And these \ns are just printing out a new line. So anytime I print this, it's going to move it onto a new line. So it'll print this guy out now on the line down, the line below. So if I was to save my program and execute it, now the computer is going to go through, it's going to execute each one of these instructions in order, and we'll be able to print out the shape onto the screen. So let's do that. You'll see over here we get our shape. And one thing I really want to stress is that order matters. So if I took this instruction and I placed it up here as the first instruction, now this is going to get printed out first. So when I run my program, you'll see that we're printing out this kind of funky looking shape. And that's because we changed up the order of the instructions, so the computer changed the order in which it executed those instructions. And you'll notice here, again, we're using this semicolon after each line of code. So that's kind of the basics of writing a program. That's essentially all you need to know. When we're writing a program, we're specifying a list of instructions that we want the computer to carry out. And depending on which instructions we give the computer and which order we give them and how complex the instructions are, that'll determine what the program does. And as we go through this course, we're going to learn more and more complex instructions. We're also going to learn how we can take simple instructions like printf and do different things with them to make our programs a lot more powerful. In this tutorial, I want to talk to you guys about variables in C. Now, when we're using C programming language, a lot of times we're going to be dealing with data. So there's going to be different data values or different information that we're going to want to keep track of and use inside of our programs. And sometimes it can be difficult to maintain and keep track of all that data. And that's where variables come in. A variable is essentially a container where we can store different pieces of information. So different data values, we can store things like numbers or text or characters. And these variables make it a lot easier for us to keep track of and manage all the data in our program. So I'm going to show you guys basically how variables can be useful and how we can use them in our C programs. So down here I have a very basic program. I'm basically just printing out a little story. It says, there once was a man named George. He was 70 years old. He really liked the name George, but did not like being 70. So this is a simple program. We're just printing out a bunch of different lines of text. And then when I run this program, you'll see we print out the actual story. So over here, we have our story. And this is great. But let's say that I'm reading through my story, I'm reading through my program, and I'm thinking to myself, I think I want to change the character's name. So instead of calling the character George, why don't we call him like John? In order to make that change, I'm going to have to look through my entire program and find every place where we mention the character's name. So right here is one, change it to John. I'm going to have to keep looking, and here's another one, so we'll change this to John, right? So I had to manually go through and change every instance of the character's name to John. And let's say that, okay, that sounds pretty good, but maybe I'm thinking I want to make the character a little bit younger. So instead of 70, why don't we make him 35? So now again, I'm going to have to look through my entire program, find every place where we mention the character's age, and change it to 35. So there and there. There you go. I changed the program, I updated it, I modified it. Now if I was to run this program, then all that information will be updated and we'll have our new story. Here's the problem though. I'm dealing with a very short story. I mean, this is 4 lines. We only mentioned the character's age and name twice. But imagine if I was writing out a huge C program that had hundreds of lines in this story. So this story had hundreds of lines, and maybe we mentioned the character's name hundreds of times. We mentioned their age hundreds of times. Well, if I wanted to change the character's age or name, I would have to go through and manually change it in every single location. And that would take forever, and it would be a huge drag. Basically, that's not a good way for us to manage and maintain the data in our programs. Right? We basically have 2 pieces of data that we're working with consistently in this program, the character's age and the character's name. What I want to show you guys now is how we can use variables to better keep track of and manage these pieces of information. So remember, a variable is basically just a container where we can store some data. So I want to create 2 variables which will store the character's name and the character's age. And I'll show you guys how this can make our program a lot easier to manage. Up here above these print statements, I'm just going to make a new line, and I'm going to come over here and I want to create a variable. Now, whenever we create a variable in C, we have to give C a couple pieces of information. So we have to basically tell C a couple different things. The first thing we have to tell C is what type of information we want this variable to store. Now, I'm going to get into the different data types that we can represent in C more in the next tutorial, but for now, just know that there's a bunch of different types of data that we can store in C. We can store things like numbers, characters, we can store text, we can store decimal numbers, all sorts of stuff like that. In our case, I'm going to store the character's name. And the character's name is basically just a collection of characters. So in order to create this variable, the first thing I have to do is tell C that I want to create a variable that's going to store characters. So to do that, I'm just going to type out char, just like that. And that'll basically tell C, hey, we're going to store characters inside of this variable. After we type out char, I want to type out the name of the variable that I want to create. Remember, a variable is a container, and it's a good idea to give these containers descriptive names. And those names will basically let us know what that variable is storing inside of it. So I'm going to call this character name. And now what I want to do is I basically want to store multiple characters. So over here, I'm telling C that I want to store a character. But in C, we can also store, instead of just storing like one single character, we can store a bunch of characters. And that would be kind of like, a name. So there's like 4 characters in here. In order to store a bunch of characters inside of this variable, after we type the variable's name, we're going to have to make an open and closed square bracket. And that's going to tell C that we want to store a bunch of characters inside this variable. So I'm going to type char character name, open and close square brackets. I'm going to set this equal to something. So I'm essentially assigning a value to this variable. And I'm just going to make an open and closed quotation marks. And inside of here, we're going to type out the value that we want to store. So in my case, I'm just going to store the character's name, which is John. And then as always in C, we're going to have to end this off with a semicolon. All right, so essentially what I did here was I created a variable and I told C what I wanted to store in the variable. I wanted to store a character. I gave this variable a name. It was character name. And I used these open and closed square brackets to tell C that I wanted to store a bunch of characters, not just one. Now what we can do is we can make another variable to store the character's age. So in this case, we're going to want to do something similar, but we're going to want to store a number. There's a bunch of different ways that we can store numbers in C, but for our purposes, we're storing a name, so we're going to use something called an integer. And an integer is basically just a whole number. So I'm just going to type out int, and that basically stands for integer, and now we're going to give this a name. So I'm going to call this character age, and I'm going to set this equal to a number. So in our story, the character is 35. So I'm just going to type out 35, and now we can again end this off with a semicolon. So I have 2 variables here. This one's storing a collection of characters. This one's storing an integer. Now the question becomes, how can we use these inside of our program? Well, basically what we can do is we can print them out alongside of this text. And we can actually use this printf instruction in order to do that. So I'm going to show you guys how to do this, and then we're going to talk about it. So basically, I'm going to go over here where we have the character's name. I'm going to erase this, and I'm going to replace it with a % and an S. And now over here, I'm going to make a comma, and I'm just going to type in the variable name. So I'm going to type in character name. And basically what's happening is when we use this %s, we're telling C that inside of this string of text here, we're going to want to insert another string. And a string is basically just a collection of characters. So I could call this up here a string variable. So when I say %s, this is basically a placeholder, and I'm telling C I'm going to insert a string into here. And over here, I use this comma, and then I type out the string that I want to include. So in our case, it's character name. And so basically over here, it's going to say there once was a man named %s, and it's going to replace %s with whatever we specify over here. So it's going to replace %s with the value that's stored inside that character name variable. So I'm going to save this, and we'll run our program. And now you'll see that it's still printing out that there once was a man named John. Even though we didn't actually type out John over here, we just typed %s in the character name. So I can do this in this other spot too. So down here, we're also using the character's name. So I can type %s, and over here we can type character name. And again, this is going to act as a placeholder for this string of characters that we specify over here. Let's do the same thing with the age. So over here we have the age is 35. I'm going to do something similar. I'm going to say percent. But now, because I have a number, instead of using %s, I'm going to use %d. And that basically means that we're going to insert an integer number into here. So I'm saying he was %d years old. And over here, I'm going to make a comma, and I'm just going to type out the name of the variable that I want to be placed inside of here. So I'm just going to be character age. And we're going to do this one more time down here. I'm going to type %d and character age. So essentially what I'm doing is I'm printing out the value that's inside of character age where I specify this placeholder. So let's go ahead and run our program, and now you'll see it's going to look exactly the same as it did before. It's the same story, the same name, and the same age, except I didn't have to actually type out the character's age and the character's name inside the story. I just referred to the variable. And what's cool about variables is I could come up here and let's say I wanted to modify the character's age. All I would have to do is modify it in this one spot. So we could change the character's name to like Tom, and we could also change their age to like 67. And now when I run my program, all of that's going to get updated in the story. So now it's using the name Tom and the age of 67. In our case, we only mentioned the character's name and the character's age a couple times, but you can imagine if I was mentioning this variable like 10 or 20 or 30 times, having to change it in each one of those individual spots would be extremely difficult. So variables are great because we can store the value one time, and then if we want to modify it, we just modify it in one place. So another cool thing that we can do with these variables is we can actually modify them. So let's say that halfway through the story, I wanted to change the character's age. I could actually come down here, I can make a new line, and right above these print statements, I could give this variable a new value. So I could say character age, and I can just set it equal to something else. So we could set it equal to like 30. And again, we want to include that semicolon. So now halfway through the story, the character's age is actually going to change. So you'll see it says there once was a man named Tom, he was 67, and then down here the age is being 30. So we actually modified the value that was stored inside of the variable halfway through printing out our story. And that's really why variables are useful. So that's kind of a basic overview and introduction into what variables are, why they're useful, how we can use them. And over here, again, we're storing a collection of characters, which is called a string, and we're also storing this integer. But there's some other data types that we can also represent. So in addition to representing like a string or a number, we can do some other stuff as well. And I'm going to talk about that in the next video. But for now, this has just been a basic overview and introduction into variables in C. In this tutorial, I want to talk to you guys about data types in C. Now in the C programming language, we're going to be dealing with a lot of data. So generally when you're writing programs, you're going to be dealing with all sorts of information. And in this tutorial, I just want to talk to you guys about what types of information we can represent and use inside of our C program. And these are called data types, right? So what are the different types of data that we can work with in our program? So I'm going to show you guys all those different data types right now. So a lot of times in C, when we're working with data, we're going to be storing that data inside of variables. So I'm just going to show you guys a bunch of different variables that we can create and all the different types of data that we can store inside of those variables. So remember, whenever we create a variable in C, we have to tell C a couple pieces of information. And the first piece of information we need to tell C is what type of data that we want to store inside of that container, inside of that variable. So let's talk about the different types of data. One of the most basic types of data, and probably one of the types of data you're going to be using the most, is going to be numbers. There's actually two very important types of numbers that we can represent in C. So the first type is called an integer, and an integer is basically a whole number, so it's a counting number, right? If I was counting on my fingers 1, 2, 3, 4, 5, I'm just counting out whole numbers, and I'm not saying like 1, 1.5, 2, 2.3, like I'm counting in whole numbers, and that's what an integer is. So to create an integer, we could just say int, and we'll give this a name, so we could say like age, and we could set age equal to like 40 or something. Now, whenever we want to use an integer in C, we always just want to type out the number. So you'll notice I'm not putting quotation marks or parentheses or anything around this. I'm just typing out the number like that. And now we actually have our variable age. Another type of number we can create is a decimal number. So this would be a number unlike an integer. So it would be like 2.5 or 8.67 or 7.538, right? It's a number that has a decimal point associated to it. So there's actually two types of decimal numbers in C. There's something called a double and there's something called a float. And I'm not going to get too much into the difference between the two of them, but as a beginner to C, for the most part, you're just going to want to use a double. So I'm just going to type out double, and this could be like someone's GPA, for example, might be like a 3.7 or whatever. So, you can use the double to represent decimal numbers. It's also important to note that I could also represent like the number 3. So I could just say like 3.0, and that's going to be a decimal. Or I could say 40.0. So the difference between 40 and 40.0 is that 40.0 is a double, it's a decimal number, and 40 without the decimal point is an integer. So that's something just to keep in mind, so you can make this like 3.6. So those are the two basic types of numbers, integers and doubles, and those are going to come in handy all the time. Now, the next type of data that we're going to want to store is going to be characters. So in C, we can store single characters inside of a variable. So I could just say char, and that stands for character, and we could give this a value. So maybe it'd be like someone's grade. And when we create a character in C, we're basically going to specify the character that we want to store inside of single quotation marks. So inside of these single quotation marks, I could put a letter. I could put like A or lowercase a. We could put H, C, D, F. Basically, you can put any character that you want to store. So if I put an A here, now this character variable grade is going to store the single character A inside of it. And it's important to note that you can only store one character. So I couldn't put like a whole bunch of characters over here. That's actually going to throw an error. All we can do is store one single character. But these three are the basic data types in C. So these are the basic types of information that we can deal with in our C programs. And just using these three data types, we can represent all sorts of information. I also want to talk to you guys about one sort of extra data type, and it's not technically a data type in C. It's technically like a modification of the character data type. So you'll notice when we create a character, we can only store one letter, one single character inside of it. But a lot of times we're going to want to represent more than one character. So we're going to want to represent like a string of characters. And generally this is called a string. So it's a collection of characters that are grouped together. And we can use this char data type in order to create a string. So I can basically say char. I can type out the name of the string that I want to create. So I could say like phrase. And then after this, I can make an open and closed square brackets. And this is basically going to tell C that we want to string a bunch of characters together. And what we're actually doing is creating something called an array. And I'm going to get into arrays later in the course. But just for now, know that we can create a string of characters by using char, specifying the name, these open and closed square brackets. And then we can create this using two open and closed quotation marks. So instead of these single quotes up here, we're just going to use double quotes. And I could type in like a phrase. So I could type in whatever string of text I want here. And this will get stored inside of this variable, which, like I said, is technically called an array. Now, it's important to note that doing something like this, so creating this like string of characters, is a little bit different from these guys up here. So like these variables up here, we could modify them, we could give them new values, but you can't do stuff like that with this. So just know that this is like a special type of data, and it's going to act a little bit differently than these ones up here. But that's sort of the basics of working with data, and those are all the basic data types that we're going to be using in our C programs. In this tutorial, I want to talk to you guys some more about the printf function. So if you've been following along with this tutorial, we've been using an instruction in our C programs called printf. And printf basically allows us to print different things out onto the screen. In this tutorial, we're going to talk more about what printf does. We're going to look at how we can use it to print out things like variables and also things like different data like numbers and strings and all that stuff. So in order to use printf, we just type out printf, and we're going to make an open and closed parentheses and a semicolon. Now printf is what's called a function, and basically what that means is it performs a specific task or a specific function. In our case, printf just prints something out onto the screen, right? The task that it's doing is printing something out. And it basically works how you'd expect it to work. So if I came in here, I could print out a specific piece of information. And generally when we're using printf, we're going to be printing out text. So I can make an open and closed quotation marks, and I could print out like hello world in here. And now this will print out onto the screen, hello. And inside of printf, I can use all sorts of special characters. So if I wanted to create a new line, for example, I can make a \n, and down here I could type world. And now this will print out a new line. So you'll see hello world on different lines. We can also use these special characters. So for example, I could print out like a quotation mark. So if I just printed a normal quotation mark right here, you'll notice that it's messing this up. So it's sort of like counting this as the entire string. If I wanted to change that, I could just put a \, here, and now this will literally render a quotation mark. So when I run my program, you can see we have a quotation mark there. And so that's kind of like the basic usage, right? You can specify some text that you want to print out onto the screen, and it'll do it. But this printf function is actually extremely powerful, and we can use it to print out different pieces of information. So in addition to just printing out plain text inside of these quotation marks, I could also print out other types of information. For example, I could print out a number. And if I wanted to print out a number, I would have to use something called a format specifier. A format specifier basically tells this printf function that we want to print out a type of data that's not just plain text like this. So if I said %, and then I said D, this would actually allow me to print out a number. So generally when we use these format specifiers, you use this %, and that tells C that you're going to want to print out something special. And then after that, we would type in a specific letter, and that'll tell C what exactly we want to print out. So if I said %D, this means that we want to print out an integer. So all I have to do now is I can make a comma, and over here, I can specify the integer that I want to print out. So I could say like 500. And now this is going to print out 500 to the screen. So you can see over here, we're getting 500. And this is cool because we can interweave these different types of data with text. So I could say like my favorite number is %D, and this acts as a placeholder for this number over here. So when I run my program, now it says my favorite number is 500, and that's really cool. We can also use multiple format specifiers. So in addition to just using this %D, I could also specify another one. So over here, I could say %S, and you'll notice that this is structured similarly to %D. %S is basically going to allow us to include some text. So I can include some more text just like this. So if I said %S, I can make another comma here, and I could say number. And now this is going to print out my favorite %S, so it's going to look for this string of text over here. It's going to insert that in, and it's going to say 500. So now when we run this, it'll say my favorite number is 500. And you'll notice here that I'm using multiple commas. So I'm saying like %S, %D, and over here I have a comma, and I'm specifying the string that I want to print, so the string of characters, and then the integer. And so basically the order that you put these format specifiers inside of your string of text is the order that you need to include them using these commas. So you're going to separate each of them using a comma. So in addition to %S and %D, we can also use a bunch of other ones. And I'm going to talk to you guys about some of the most common. %D will print out an integer like 500, but if we wanted to print out a decimal number, for example, a double, we could say %F, and this is going to allow us to print out a decimal number. So I could say like 500.98754. And now this is going to print this out onto the screen. And actually, I need to build this. So my favorite number is 500.9875540. So essentially, you can use these printfs and you can use these format specifiers in order to include different data types into your output. So like this is just some general text output, and we can use these different guys to interweave like numbers or other strings and stuff like that. And where these really become useful is when we have variables. So if I was to create like a number variable up here, I could call it like favnum, set it equal to 90. I can use this variable and print it out inside of this printf. So over here, we could make this %D, And instead of printing out this number, we can just access that variable. So I could say fav num. And this will allow me to print out that variable using that printf function. So my favorite number is 90. So that's the basics of using printf. This is a very awesome tool that we can use. And printf is basically just used for us to find out information. So when we're running our programs, a lot of times we're going to want to be able to get some information about what's going on, about what they're doing. And printf can allow us to do that. So don't be afraid to use these different access modifiers. Like I said, %s, %d, %f, those are all sort of the common ones. And you can also use %c, and this will allow you to print out a single character. So I can come over here, create like a character variable. We'll call it mychar and just set it equal to like lowercase I. And I could print this out using %c. So now we could say mychar. And you'll see that we print out I. So play around with printf. It's extremely useful, and it's really going to come in handy when we're writing more complex programs. In this tutorial, I want to talk to you guys about working with numbers in C. Now, a lot of times when we're writing programs in C, we're going to want to do different things with numbers, whether that's just storing numbers and keeping track of them, or adding, multiplying, subtracting, doing math with numbers, or really just dealing with numbers in general. So I'm just going to give you guys a basic overview of a lot of the stuff we can do with numbers. We're also going to talk about how different number types interact, so how like integers and doubles interact and all that fun stuff. So down here, I am printing out a number. So you can see I'm using this printf function. And inside of these quotation marks, I'm basically saying %f, and %f stands for like a floating point number. So that could be either a double or a float, basically a decimal number. So when we put %f in here, it's going to allow us to print out a decimal number, just like this. And you can see I can run my program and it'll print out 8.9. You'll notice that it's printing out not just 8.9, but it's also printing it out to a very precise decimal point. And that's what C is always going to do. So it's always going to print it out to a very precise decimal. So using these decimals, I can do all sorts of stuff. So obviously I can just print out the decimal, but I could also do things like math. So I could say like 5.0 plus 4.5. And this is going to go ahead and be able to do that for us. So when I run my program, not only is it gonna like print this out, but it's gonna do the actual math operation. And you see we get 9.5. So in addition to addition, we can also use subtraction, division, which is gonna be a /, and multiplication, which is gonna be an asterisk. And you can use all these different things to do the 4 basic math operations: addition, subtraction, multiplication, and division. So now I wanna talk about how we can use floating point numbers, so like doubles and floats, alongside integers. So let's say I was going to add an integer with a double. So if I said 5 plus 4.5. Well, actually, when we do this, this entire answer is going to get converted into a decimal number. So when I say 5, which is an integer, plus 4.5, we're going to get a floating point number back. So we're going to get 9.5. And basically any operation that you do between an integer and a floating point number is going to return a floating point number back. So that's important to realize. But if I was to change this to 4, now this isn't going to work anymore because this is asking for a floating point number and we're giving it an integer. So when I do math with 2 integers, it's going to give us an integer back. And if I do math with a floating point number and integer, it'll give us a floating point number back. It's also important to realize, for example, if I took 5 and divided it by 4, this should actually be a decimal number, right? And you'd expect us to get a decimal back. But if I just printed out %d, so if I printed out the result of the integer 5 divided by the integer 4, I'm actually going to get an integer back. So when I run the program, you'll see we're getting a 1 here. But really, the answer is 1 technically, but it's 1 with a bunch of decimal points after it, right? It's 1 plus a bunch of other stuff. But when we just do math with 2 integers, we're going to get an integer back. If I was to say 5 divided by 4.0, and I printed out a decimal, now we're going to get the entire answer back. So we're going to get 1.25. So that's just a little bit about dealing with integers and floating point numbers. We could also take these and put these into variables. So, in addition to just having numbers down here, I could specify a variable like, num, set it equal to 6. And we can go ahead and print num out down here as well. I'm gonna need to make this a D. So now we'll be able to print out that variable with no problem. So it can be really useful sometimes to store these numbers inside of variables. I also want to talk to you guys about using more complex mathematical functions. Now in C, we have these things called functions, which are basically just little blocks of code that we can call. And when we call them, they're going to go off and do certain things for us. So they'll like modify a value or give us information about a value. And these functions can be really useful. I'm going to show you guys a couple functions that we can use with math. So I'm just going to come over here and I can actually start using these functions. And all you have to do is just type out the name of the function that you want to use. So by default, C is going to give us access to a bunch of math functions that we can use. So we really don't have to do anything. All we have to do is just type in their names. And I'm going to show you guys one. It's just POW. So I'm just typing in POW. Then I'm going to type in open and closed parentheses. And inside of this parentheses, I can actually give this two numbers. What this is going to do is it's going to take the first number that we give it, and it's going to take it to the second number. So if I said like 2 and 3, and you'll notice I'm separating them with a comma, this is basically going to give us 2 raised to the third power. So it'll give us 2 cubed. So when I run my program, and actually we need to print this out as a decimal number. So this is going to give us a decimal number back. So I need to print this out with F. When I run my program, we're going to get 8 back, just like that. So it's basically cubing 2. I could say like 4 raised to the third power, and now we should get back 64, which we do. So that can be pretty useful. There's a couple other ones I'll show you. Another one is SQRT. So this will allow you to take a number's square root. So if I said like 36 in here, now we're going to print out the square root of 36, which is going to be 6. And there's a couple other ones. So let's say that I had a decimal. I could say CEIL, which stands for ceiling. So if I had like 36.7 or 36.356, this is going to give us the next highest number. So it'll basically round this number up. And this is going to give us 37, as you can see. We can do another one, which is called floor. And floor will do the opposite. So floor will just round the number down no matter what. So if I had like 36.656, this will round it down to 36. So there's all sorts of little, things we can do, little functions that we can call and get information about numbers. And like I said, these functions will either like modify a number, so it would like give us the floor or the ceiling, or sometimes they'll like give us information about numbers. So that's sort of the basics of working with numbers. You can do all sorts of math with numbers. You can add and subtract, multiply, and you can even multiply, add, subtract integer numbers and floating point numbers. So play around with all these different things with numbers. And if you want to find some more of these little math functions, all you have to do is just go online and Google search for C math functions. There's like dozens of these little functions that you can use. But I think these are some of the most widely used. In this tutorial, I want to talk to you guys about using comments in C. Now, a comment is a special block of code in C which actually gets ignored when we run our program. So if you want to write a comment, you can use a special starting and ending tag, and any of the text, any of the code, anything that you put inside of that tag isn't going to get executed or really looked at by C. So we can use comments to do all sorts of things. You can leave little notes or little comments inside of your program. You can use comments to temporarily disable certain lines of code. They can be really useful. So I'm going to show you guys the basics. Down here in my program, if I want to create a comment, I can start a comment using a / and an asterisk. And you'll see when I put this asterisk in, all the code in my text editor changed color. And basically what this means is anything that comes after this / and asterisk is going to be considered a comment. In order to close off the comment, I can use another asterisk and another /. You'll see the code changed back to normal code. Inside of these two asterisks, I can basically write out anything I want and it's going to get considered as a comment. So for example, if I, wrote out like my program and I ran my program, this whole thing is going to get ignored by C. So it's just going to print out comments are fun. It's not going to do anything else. And like I said, comments are really useful. So I could leave a little note up here. I could write something like to do, like I have to do something. And a lot of times people will use comments to explain certain lines of code. So I could put a comment here and I could say like this print out text, right? So maybe, this was like a really complex line of code. We could use this text in order to explain it. You can also use comments to do something called commenting out a line of code. So for example, let's say I wanted to run my program, but I didn't want to have this line of code in there. Well, one thing I could do would just be to delete the entire line of code, right? So I could delete this code, and now I can run my program and it's no longer gonna print it out. It's no longer gonna do anything. But here's the problem. In order to do that, I had to actually delete the line of code. So instead of deleting it, I could just bring it back and I could comment it out. So I could basically surround it with these comment tags, and now the computer is just gonna ignore it. So it's not gonna render it because it's been commented out. So now when I run my program, it's gonna do the same thing. It won't execute that line of code, but I didn't have to actually delete the line. I could just comment it out. So a lot of times when you're writing programs, you might want to try to run your program without a certain line or a certain series of lines of code. And instead of deleting them and then running the program, you can just comment them out and C will basically ignore them. So that can be really useful. So those are the two basic uses for comments, and essentially comments are open, right? It's just a way that we can write out information in our files that won't get rendered by C. And so you can really use comments to do whatever you want. Now I will say one best practice with comments is to use them sparingly. Generally, you only want to use a comment when you absolutely have to. So it can be really annoying if you open up a C file and there's like comments littered all around. And obviously if you want to put a bunch of comments in your code, I mean, no one's stopping you. But as a best practice going forward, I think generally only using comments when they're absolutely necessary is kind of like a good practice. But again, it's open, you can use comments for whatever you want. In this tutorial, I want to talk to you guys about constants in C. Well, constant is a special type of variable in C which can't be modified. So when I create a constant in C, I'm basically creating a value that is unable to be modified. So I'm going to show you guys basically how this works. Let's say I created a variable. Let's say I created an integer and I just called it num and I set it equal to 5, right? And then I printed out that integer onto the screen. So we can print this out, %d, and I'm just going to print out num, right? So I can create this num variable, I can print it out onto the screen. Let's say that down here I wanted to modify num. So I could basically say num is equal to 8, so I can modify the value that's stored inside of the num variable. And let's come down here and we'll print this out as well. So %d, and we'll print out num again. And actually I'm going to print out a new line here. So when I go ahead and run this program, and I forgot a semicolon, when I go ahead and run this program, you'll see we're printing out 5, and then we modified the value to 8, and then we printed out 8. So I was able to modify this value down here. I was able to modify num. But in certain circumstances in C, you're going to want to create variables, or you're going to want to create values that can't be modified. So these would be values that just like can't change, and those are called constants. So if I wanted to make num a constant, in other words, let's say for some reason I didn't want the num variable to be able to be modified in my program, I could come over here and I could say const, so C-O-N-S-T, and I'm going to say that right before I declare the type. Now you can also say const right after you declare the type, but I've always preferred to just put it before. So I say const int num5, and now this program is actually going to throw an error. So when I try to run this, you'll see down here it's getting highlighted in red. That's because I can't modify a constant. So I'm trying to modify num down here, but I can't because I gave it this const keyword, because it's now considered a constant. So in a lot of cases, you'll want to have variables that just can't be modified, can't be changed. And in a situation like that, you want to make them constants. Also, a lot of times when we make constant variables in C, we'll give them all uppercase names. And this isn't required. This is just sort of like what a lot of developers will do. So they'll say, like, instead of num like this, they would say like num. Or maybe this is like your favorite number, so you could say fav_num. So that would be how you could like distinguish two words. But generally, like, constants will be all capital, and that's just so it's kind of obvious that they're unchangeable, that they're constants. But again, you don't have to do that, but that's kind of like a best practice. So this is one way that we can create a constant, and we basically create a constant variable that can't be changed. But a constant could also refer to just like any number or any text that we're using in our program. So for example, I'm gonna get rid of this. If I came down here and I just like printed out some text, so let's say I just printed out like hello, this is actually also gonna be considered a constant. So this is just like a string of characters, a string of text. That's also considered a constant because it's just like text on the screen. We can't change it, we can't modify it, it's just kind of there. So you would also consider this a constant. If I was printing out a number too, like let's say I came over here and printed out 70, 70 is also considered a constant. So it's just considered to be like a piece of information or a piece of data in our program that is sort of unchanging, right? So 70, this isn't gonna change. I mean, unless I physically came in here and changed it, like this value is always gonna be 90 no matter what. I can't modify it unless I like manually come in and modify it. So that's also considered a constant. But I would say like for the most part, like where this is gonna come in handy is obviously doing stuff like this, but creating constant variables, variables that can't change. In this tutorial, I'm going to show you guys how to get input from a user in C. So a lot of times in our C programs, we're going to be working with all different types of information. And a lot of times we're going to want to get some of that information from the user. So I'm going to show you guys how we can prompt the user to enter in some information. We can take that information, store it inside of variables, and then we can use it inside of our program. So this is going to be pretty cool. So down here, I will basically write out the code for this. And the first thing we want to do whenever we're getting input from the user is we want to prompt them. So I want to prompt the user, as far as what they should enter in. So I'm just going to say printf, and over here, I'm just going to print out a prompt. So why don't we ask the user to enter in their age? So I'll show you guys how we can get a number from the user. So I'm just going to say enter your age. And now that we've prompted them to enter their age, I need to do two things. So the first thing I want to do is create a variable where we can store the input that the user puts into the program. So I want to create a variable where we can store the age that the user inputs. So I'm going to create an int over here. I'll just call it age, and I'm not going to give this a value. So all I'm going to do up here is just declare the variable. I'm just going to tell C that I want to use this variable, but I'm not going to give it a value. In other words, I'm going to allow the user who's inputting the age to give this a value. So down here, I want to be able to get input from the user. So I can use another function which is called scanf. And scanf is basically going to allow the user to enter in some information into our program. And this works similar to printf. It's kind of doing the opposite of printf, right? Printf is printing something out onto the screen. Scanf is allowing the user to input something into the program. And I'm going to make an open and close quotation marks. And in here, I basically want to tell C what type of information I'm asking the user to enter in. So in our case, we're asking for an integer, right? Age is going to be an integer. It's a whole number. So I'm going to accept as an input an integer. And over here, we want to tell C where we want to put that integer. So I'm basically going to tell C what variable I want to store this in. So I'm going to store this inside of my age variable. And I can essentially just type out the name of the variable here. But in order to get input from the user, I'm actually going to have to type an ampersand in front of this. So instead of just typing out age, I'm going to have to type ampersand age. And when I say ampersand age, this is what's called a pointer. And we're going to talk about pointers in a later tutorial. I'm going to cover everything you need to know about pointers. But for now, that's a little bit beyond what we need to learn. So all you need to know is that when you're using scanf and you want to store information inside of like an integer or a float or like a character, you need to use this ampersand over here. So down here, now that we've scanned for the user's age, I'm just going to go ahead and print it out. So we'll just print out like you are, and I'll say %d years old. And over here, I'm just going to print out that age variable. So essentially what I'm doing is I'm prompting the user to enter their age. I'm storing whatever age they enter inside of this age variable, and then I'm printing it out to them. So let's go ahead and run this program and we'll see how we did. So I'm going to run the program and it says enter your age. So let's say someone is 50. When I click enter, it's going to take that value. It's going to take that integer that we entered, 50, store it inside of that age variable and print it out. You'll see over here it says you are 50 years old. So that's how we can get an integer from the user. We can also get like a double from the user. So for example, I could say enter your GPA. And so now instead of asking for an integer, we're going to be asking for a double. So I could come up here and say like double, and we could call this GPA. And now I can do the same thing. But instead of saying D, I want to say LF. And LF is basically going to tell this scanf function that we're looking for a double. And then obviously instead of age, we're just going to put GPA inside of here. And so now we can just say like your GPA is, and then we can put %F because we're going to be printing out a double, and I'll just say GPA. So you'll notice here in printf, when we want to use a double, we're using %F to print it out. But when we're using scanf, we're going to use %LF. So that's just like a little difference. And now let's go ahead and run this program, and we should be able to get a GPA. So let's say someone's GPA is like 3.1. Now it says your GPA is 3.1. So that's how we can get a double. I also want to show you guys how we can get a character. So why don't we create a character up here, and we'll just call it grade. And we'll say enter your grade. And now when we want to get a character, we can just say %C. And again, I can just come down here and say ampersand grade. And then down here, we can just say your grade is %C. And we'll go ahead and print out the grade. So now we should be able to get a character from the user. So enter the grade. Let's say I got an A, and it says your grade is A. So we can use this scanf to get specific types of input from the user, and we can store those specific types of input inside of variables. Now I also want to show you guys one more thing we can do, which is we can actually get a string from the user. So in addition to getting numbers and a character, we could also get like a string of characters from the user. And this is going to be a little bit different from doing like numbers and characters. So I want to kind of show you guys how we can do this really quick. So over here, let's create a variable. We'll just call it, let's just call it name. So we'll be storing someone's name. And whenever we're creating a string of characters, we always need these open and close square brackets. And inside of here, I'm actually going to specify how many characters I want to be able to store inside this string of characters. So I'm just going to put 20. And in the past in this course, when we've been creating strings, we haven't put a number in there. We've just kind of said like whatever, right? We've basically just given this a value straight away. But in this particular situation, we're not going to be giving this variable a value right away. In other words, like I don't know what the user's name is going to be. Like I don't know that right up front. They're going to tell us what that is. And so if I'm not going to give this a value right away, I do actually need to tell C how big I want this variable to be. In other words, I need to tell C how many characters I want this variable to be able to store. And that way C can go ahead and allocate enough memory for this variable. So I'm just going to put 20, and 20 basically means this will be able to store 20 characters. And I think that's enough for a name. So down here, we'll just say enter your name. And I can use scanf in order to get input in the form of a string, but instead of saying %C, I'm just going to say %S. And over here, instead of saying ampersand grade, I'm just going to type out the name of the string of characters. So I don't actually need this ampersand here. I can just specify the name of the string. So down here it says printf your grade is, and actually let's just say your name is, and we'll just say %S. And then over here we can print out the name. So this should work just like it did in the other cases. So let's go ahead and run this. And it says enter your name. So my name is Mike. And you'll see it says your name is Mike. So that works out really well. But there is one problem when we're using scanf in order to get a string from the user. So for example, if I came in here and I said enter your name and I said my name was John Smith. When I click enter, you'll notice that it's only saying your name is John. It's not including Smith over here. And here's the problem. This is because whenever I use this scanf function and I use it with a string, it's only going to grab the characters up to the first space. So once it sees this space, it's going to be like, okay, we're done getting characters, right? So that's kind of a problem. And that's just kind of how scanf works. It's not really, scanf's fault. There is a way that we can modify scanf in order to be able to get input with spaces. But there's another function which I want to show you guys, which we can use to get a line of text from the user, and it's called fgets. And fgets is another function. It's similar to scanf, but fgets is basically going to be more general. So fgets is essentially just going to grab like a whole line of text. It's not going to be able to grab it and store it inside of like an integer or a variable or a character. It's just going to be able to store it inside of like a string of characters. So when we're using fgets, the first argument we want to give it is the name of the variable where we want to store the line of text. So in our case, it's just going to be this name variable. The next thing we want to do is specify how many characters we want to be able to input from the user. So this will essentially limit the amount of characters that the user can input. And this is always a good idea when we're trying to get a string from the user, because one common problem is that the user could try to enter in like 1,000,000 characters and they would overflow the buffer. In other words, like C wouldn't be able to handle accepting that many characters and the program might break. So over here with fgets, we can specify how many characters we want to be able to accept. So I'm just going to say 20 because that's how many characters we can store inside of this variable. And over here, I'm just going to say stdin. And this stands for standard input. Essentially what we're doing over here is we're telling fgets where we want to get the information from. And standard input is essentially just like that little console that we've been using. So now I'm using fgets, and this is going to do exactly what scanf did. So we'll be able to store the input inside of this name variable, but now we'll be able to store multiple words instead of just one single word. So let's run this program, and it says enter your name. So now if we entered in John Smith, you'll see it's able to enter in John Smith. Now, the one downside with just using this fgets is you'll notice that it printed out this new line over here. So let me actually demonstrate this a little bit. So if I was to print out like, just some random text over here, whenever I get input using scanf, so if I entered in John Smith, when I click the enter key, so when I'm entering this by clicking the enter key, that's actually going to represent a new line character, and that's going to get stored inside of the string. So when I click enter, you'll notice it says your name is John Smith, and then it prints out a new line character and it prints out this text. And so that's just something that you need to be aware of when you're using this fgets function. But for the most part, I would say if you're getting input from a user in the form of a string, you can use fgets. You could also use scanf, and you could use multiple %s's, and I'm actually going to show you guys how we could do something like that in a future tutorial. But for the most part, I would say whenever you're getting a string from the user, you just want to use fgets. So that's the basics of getting input from the user. Like I said, there's a couple other things that we can do, and I'm going to talk about at least one other way that we can get strings from the user in a future tutorial. But this is kind of the basics, and you can kind of play around with doing this stuff in your programs. In this tutorial, I'm going to show you guys how to build a basic calculator in C. We're basically going to build a little program where the user can enter in two numbers, and then our program will take those two numbers, add them together, and spit out the answer. So this is going to be kind of cool, and we'll also learn about getting numbers as input from a user. So over here, I want to show you guys exactly how we can do this. The first thing I want to do is print out a prompt. So I basically want to prompt the user for some input. So over here, I can just say printf, and inside of here, we're just going to give them a little prompt. So I'll say enter first number. And essentially what we're going to have them do is enter in two numbers. So I'm actually going to create two variables up here. So we'll make an int, and we'll call it num1. And then we'll make another int, and we'll call it num2. And I'm not actually going to give these values right up front. We're going to end up giving these whatever the user enters in. So after the user enters the first number, we need to actually grab that number. So I can use another C function called scanf. And in here, we're basically just going to say %d because we want to grab an integer. And then over here, I'm going to say the name of the variable where I want to store the value that gets entered. Now, if you're following along with this course, in the last tutorial, we were able to get a string of characters as input from the user. And basically, we just typed in like the name of the variable. But when we're getting input that's not a string of characters, in other words, when we're getting input that's not %s, So if it's like %D or %F or %C, so if it's like a decimal or an integer or a float or a character, we actually need to use a special symbol, this ampersand. So I'm gonna have to say ampersand and then the name of the variable where I want to store this value. So I'm just gonna say ampersand1. And basically what this means is we're accessing the address of num1. And we're gonna talk about addresses and pointers in a future video. But for now, just know that you need this ampersand here in order to store the value that gets entered inside of this variable. So once we do that, now we can move on. And we're basically just gonna do the same exact thing, but for the second number. So I'm gonna copy these and I'll paste this. And now instead of saying enter first number, we'll say enter second number, and we're just gonna store this inside of num2. All right, so once we're done with this, the last thing we wanna do is add them together and print out the answer. So I'm just gonna come down here, I'm gonna say printf, and we'll just say answer, and over here we'll print out the answer. So it's gonna be an integer, and we're basically just gonna print out num1 plus num2. So we're gonna print out the value of num1 plus num2. So we have our basic calculator. We're getting the first number, we're getting the second number, we're storing them inside of these variables, we're adding them together and printing them out. Let's try to run our calculator. So I'm gonna run my program, and you'll see over here it says enter first number. So let's go ahead and enter 6. Enter second number, we'll enter a 8, and now we're gonna get 14. So 14 is the correct answer. So our program worked. It was able to add the numbers correctly and everything's awesome. But let me show you guys one problem with this program. If I wanted to do math on decimal numbers, for example, if I said 2 and then over here I said like 6.8, when I add these together, we're not gonna get the correct answer. We're gonna get 6 plus 2, which is gonna be an integer 8, but we're not gonna get 8.8. So we're not getting the correct value. So instead of letting the user enter in only integers, why don't we instead let them enter in doubles? So over here, I'm gonna change these to double. So I'm gonna say num1 is gonna be a double, num2 is gonna be a double. And since we're getting doubles as input, we're gonna have to come down here and modify these. So right now, this is accepting an integer, but we wanna make this accept a double. So normally if we're using printf and we wanted to print out a double, we would say f, and that stands for like floating point number. But when we're scanning for a number, if we want to use a double, we have to say LF, just like that. So down here, I'm also going to say LF, and we'll change this to just F. So printf is a little bit different than scanf, right? In scanf, if we want to accept a double as input, we need to use LF. In printf, we just use %F. So let's run our program now, and we should be able to add floating point numbers. So decimal numbers. Over here, we'll do 4.5. plus 6.7, and we get 11.2. So that looks good to me. Looks like everything's working properly. And now we have a basic calculator, so the user can enter in any numbers that they want, and the calculator will be able to handle them. Now, this calculator is not like 100% ironclad secure. For example, like if I was to come up here and enter in like a string of characters instead of a number, you'll see that it's gonna break the program, right? So it's just like not doing what we wanted it to do. And as we go further in this course, we're gonna learn all sorts of ways that we can check to see if certain things are getting entered correctly, and we could basically mitigate circumstances like that. But for now, this is just kind of an introduction into how we can get numbers as input and do things like addition or multiplication once we have them. In this tutorial, I'm going to talk to you guys about building a little game in C. More specifically, we're going to be building a Mad Libs game. Now, if you've ever played the game Mad Libs, it's basically a game where you write down a bunch of random words. So it could be like, nouns or verbs or someone's name or, a verb ending in ing, something like that. You take all of those words that you enter in and you kind of sprinkle them into a story. And then generally the story is like kind of funny because it has all these random words in it. So actually, if we head over to my web browser, you'll see I have a picture of a Mad Lib up here. And basically, you would just add in a bunch of random words into the story, and then you'd read the story back, and it could be kind of funny. So I'm going to show you guys how we can build something like that in C. And we're also going to talk about some more ways that we can use that scanf function that I showed you guys in the last tutorial. So over here, we have a little story that I printed out. It just says, "Roses are red, violets are blue, I love you." Kind of like a classic poem. But I think this poem would be a lot funnier if we turned it into a Mad Lib. So that's exactly what we're gonna do. I'm gonna replace roses are red. I'm gonna replace red with a random color. So we're just gonna have the user enter in a color. I'll replace violets with a plural noun. So we're gonna have them enter in a plural noun. And I'm gonna have, instead of saying I love you, we're gonna say I love and then a specific celebrity. So I'll just type in celebrity right there. All right, so this is basically what we're going to be printing out. We're going to be printing out roses are, and then whatever color they enter in. Plural nouns are blue, and then I love whatever celebrity. So let's talk about actually creating this program. So we're actually going to need to do a couple things. And actually the first thing I want to do is I want to create variables. We're going to create variables to store the color that the user inputs, the plural noun that the user inputs, and the celebrity the user inputs. We're going to create 3 variables. And these are basically going to be character strings. So they're going to be collections of characters, and we can store them in a variable. So I'm going to create some of these variables. Why don't we create one for color? And remember, whenever we create a string or like a collection of characters, we need to make these open and closed square brackets. And what I also want to do, because I'm not going to be giving color a value right away, in other words, we're letting the user determine the value of color, I just need to tell C how many characters we want this string to be able to store. That way C knows how much memory it needs to allocate for this variable. So I'm just going to say 20, and we'll basically just say they can enter in a color that is up to 20 characters. We're going to do the same thing for plural noun. And again, we'll let them enter in 20 characters maximum. And finally, we're going to do the same thing for celebrity. So again, 20 characters sounds good. All right, now that we have our variables created, I want to actually get information from the user. So I want to prompt the user for information, and I want to take the information that they entered in, and I want to store it inside of each one of these variables. First order of business is to prompt them for input. So I can just say printf, and inside here, we'll basically just type in enter a color. Once we've prompted them to enter the color, we can actually get whatever color they enter and store it inside of a variable. I'm going to use a function called scanf, and over here I'm going to accept a string. So I'm going to accept a string of characters, and we're going to store this inside of our color variable, just like that. And remember, if you watched the last tutorial, we used the ampersand here when we were getting numbers, or also you do the same thing if you were getting a single character. But when we're getting input for a string of characters, we don't need that ampersand, so you can just get rid of that. Let's copy these, and I'm going to paste this 2 more times. So the second thing we want to get from them is going to be the plural noun, and I'm going to store this inside of the plural noun variable. So you can see now we're getting the plural noun, and finally we're going to do the same thing for celebrity, and again we're going to get that celebrity. Okay, cool. So now I'm getting the color, I'm getting the plural noun, and I'm getting the celebrity. So the last thing we have to do is we have to take all of these variables and put them into our story, right? So we need to be able to print out the story with all of those variables. So I'm going to come down here, and I'm just going to say %s, and over here we'll pass in the color. Same thing here, I'm going to replace the plural noun here with a %s, and we'll pass in the plural noun. And finally, same thing for celebrity down here. All right, so everything seems to be wired up, and you'll notice that I have new lines here so that this story prints out on new lines. Let's go ahead and run this program, and we'll see how we did. So over here, it's prompting us for a color. Why don't we enter in magenta? Enter a plural noun. Let's do microwaves. And enter a celebrity. Why don't we just say Prince? So when I click enter, it's going to say roses are magenta, microwaves are blue, I love Prince. So we were able to prompt the user to enter in all of that input. We took everything that they input, we stored it in variables, and we printed all those variables out inside of our story, and we have our Mad Lib. The program seems to be working really well. I do want to show you guys one way that this program could mess up. So let's go ahead and run this again. So let's enter in a different color. I'm going to enter in like blue, enter in a plural noun. So why don't we enter in phones? And now enter in a celebrity. So I'm going to show you guys one way that we could actually break this program. If I entered in a celebrity with a first and a last name, like Tom Hanks, when I click enter now, you'll notice that instead of saying I love Tom Hanks, it's only saying I love Tom. Here's the problem. When we use that scanf function, scanf is only going to grab characters up to the first white space. So essentially when we put this space here, we're telling C that we don't want to grab anymore. But in reality, we want to be able to grab the actor's full name. We want to be able to grab the celebrity's first and last name if need be. So this is a situation in C where we would have to modify our little program. So what I could do is, instead of just getting one variable like the celebrity, I could actually get two. So I could say over here like celebrity F, and that'll stand for celebrity first name. And then down here we can make another variable called celebrity L. That'll stand for last name. So now when we scan, instead of just scanning for one string of characters, I can scan for two strings of characters. And we'll have celebrity F and then celebrity L. And down here, we're going to want to do the same thing. So we can just say celebrity F and celebrity L. And we just need to add another % here. So it's going to say I love celebrity's first name and celebrity's last name. So let's run our program and see how we did. So I can enter in like red and microphones. And now we can enter in Tom Hanks. And we're printing out the actor's first and last name. So that's one way that we could remedy this program and make it be able to accept two inputs with a space in the middle. And that also just shows you guys a little bit more about how scanf works. So it's going to stop scanning. It's going to stop getting the input at that first space. Now, here's the thing about this program, though. If I wanted to enter in a celebrity with who only had one name, so if I only wanted to enter in one, the program actually isn't going to be able to handle that. So if I said like hats, and down here if I said like Gandhi and I click enter, you'll notice that it's still waiting for me to enter in a last name, right? So I can enter in something here and then the program will work, but it was waiting for me after I entered in just that one name. So that's something that you're going to have to, play around with in your programs. Basically, C is going to force you to be very specific about what the user's entering. So if the user needs to enter two things, like two words, then you need to specify that. If the user is only going to enter in one word, you have to specify that. So you have to be very specific when you're getting input from the user like that. In this tutorial, I'm going to talk to you guys about using arrays in C. A lot of times when we're writing our C programs, we're going to be dealing with a bunch of different data. And one of the things we can do to control and manage and sort of keep track of and organize that data is put data inside of things called arrays. And an array is really useful because it's basically a container where we can store a piece of information. But what happens in your programs when you're dealing with huge amounts of information? Specifically, huge amounts of information that are related. Right? Imagine I had a list of like a bunch of names or a list of a bunch of numbers that I needed to keep track of. Let's say I had like a list of 100 numbers, right? I wouldn't want to have to create 100 different variables to store all of those different numbers. And this is where arrays come in. An array is essentially a data structure where we can store a bunch of different data values. So inside of an array, unlike a variable where I can only store one value, I can store hundreds or thousands or even millions of values. So inside of a single array, I could store like 5 things or 7 things or 10 numbers or 20 characters. I could store a bunch of different pieces of information, and then all that information would be nice and neat and organized in my program. So I'm going to show you guys how to create arrays. We can create an array a lot like we create a normal variable. And a variable and array are very similar, right? A variable is basically used to define a container that stores a single value. And an array is used to define a container that stores, any number of values. So the first thing we're going to have to do when we create an array is give C some information. And the first piece of information is what type of data we want to store inside of the array. So for example, I could say int, and now I'd be creating an array that would hold integers. If I said char, I'd be creating an array that would hold characters. Or if I said like double, same thing, but for double numbers. So why don't we create an array of integers? And I'm just going to call this lucky numbers. Whenever I create an array, I always want to use a special little symbol. And this symbol will tell C that instead of just creating a normal variable, we want to create an array. And it's an open and closed square brackets. Whenever I use these open and closed square brackets after the name, it's going to tell C, like, okay, we want to store multiple pieces of information. Now, there's a bunch of different ways we can create these arrays. The easiest one, though, is to just say equals, and I can make an open and closed curly bracket. And inside of this open and closed curly bracket, I can just start typing out some numbers that I want to put in this array. So we could type out like 4, 8, 15, 16, 23, 42. Now, I could basically type out as many numbers as I wanted, and I could store them inside of this array. So over here, I printed out 6 numbers. I could print out 600 if I wanted. The only thing that's limiting me is how many I can actually put in here. So you'll notice that I put in the piece of data, so like 4, for example, and then I put a comma. And a comma is going to separate all the elements in the array. So we would say 4 is the first element in the array, 8 is the second element in the array. These are all considered to be elements inside of this array. And what's cool about this array is it's now storing all of this information. So unlike a variable where we can only store one value, now in this array I'm storing 6 different numbers. So if I wanted, I can print this out, and I'm actually going to print this out just to show you guys. So remember, we're going to print out a number, and I'm going to show you guys how we can access specific elements inside of this array. So all of these numbers are stored in this lucky numbers array, in this array structure, but the question becomes, how do we access them, right? How can I gain access to one of these? Well, I could say %d, so I'm going to print this out, and now I can just say lucky numbers, so I'm going to refer to the name of the array, and when I want to access a specific element, I can make an open and closed square bracket, and inside of this open and closed square bracket, I want to put the index of the element that I want to access. So all of these elements in here have a specific index, and I can access them by putting the index inside of this square bracket. So if I wanted to access this 4, for example, I can put a 0 inside of here. And now when I run my program, you guys will see that we'll be able to print out that 4. So over here, I'm printing out 4. If I wanted to access this 15, I can put a 2 in here. So now when I run my program, I'll be accessing the 15, as you can see. So one thing you might have noticed by now is that we start the indexes in arrays at 0. So when I wanted to access this 4, instead of putting a 1 in here, I put a 0 in here, right? You might think that 4 would be at index position 1 because it's the first element in the array, but in C, we start array indexes at 0. So actually the first element, this 4, is going to be at index position 0. So if I was going to write out indexes, I would say like 4 is at index position 0, this 8 is at index position 1, this 15 is at index position 2, 16 is at index position 3, etc. So that's going to allow me to access all of these elements inside of the array individually. So I could print them out just by referring to the index inside of these square brackets. Another thing I can do is I can modify some of the elements inside of here. So let's say I want to modify lucky numbers index position 1. So let's say I want to modify this 8. So I don't like this 8 anymore, so I could basically just assign this a different value like I normally would. So I could say lucky numbers, and I can make an open and close square bracket. We can say 1, and I can just set it equal to something else. So I could set this equal to like 200. And now when we print out lucky numbers 1, instead of printing out an 8, it's going to be printing out a 200. So let's go ahead and do that. I'm going to run my program, and you'll see we're printing out 200 instead of 8. So you can modify any of the individual elements inside the array just by referring to the index. And really, when you think about this conceptually, an array is basically just holding a bunch of variables, but those variables don't have names. So when I access lucky numbers 1, it's the same as me accessing an integer variable. It's just that, the array is holding potentially hundreds or thousands or millions of these different variables. So an array is a very useful structure, especially if you're storing data that is very similar. So like I said, I could do this with an int, I could also do this with a double, I could do this with a float, I could do this with whatever I wanted. But there's going to be situations where you might not necessarily know all the elements that you want to put inside your array. So let's say I'm creating an array and I don't know what numbers I want to put in it yet. So maybe I just want to create it, I want to tell C that we need it, but I don't want to necessarily put anything in it right away. Well, up here, we're basically saying lucky numbers, the open and closed square brackets, and then we're giving it a bunch of information. But if we don't want to give it all that information, instead, I can just put a semicolon here. But inside of these square brackets, I need to tell C how many elements that this array can hold. So I need to tell C, like, hey, this array can only hold like 10 elements, or this array can hold 20 elements, or whatever. So let's say we wanted an array that could hold like 10 elements. I can put a 10 right here, and now the capacity of this integer array is 10. So it has the potential to hold 10 items. And what I could do is I could come down here and I could start assigning values to those items. So I could say like lucky numbers 1 is equal to 80, right? So I'm giving lucky numbers 1 a value. And now over here I could print that value out onto the screen. And you'll see we're printing out 80. But if I tried to print out, for example, lucky numbers 0, so the lucky numbers at index position 0, this is going to give me a -2, which basically means that it's not found. So basically means that there's no element inside of lucky numbers at index position 0. But if I wanted, I could do that. So I could say like lucky numbers 0 is equal to 90. And now when I run my program, it's going to be able to do that. So it'll be able to get that value. So in a lot of situations, you're just going to want to give these arrays values up front right off the bat. But in a lot of other situations, you're not going to necessarily know what's supposed to go in there. But in a situation like that, you still have to tell C how many elements the array is going to hold. You still have to like rigorously define like, hey, this array can only hold 10 elements. And that's just so C is able to allocate enough memory in order to hold all of those elements. So that's kind of the basics of working with arrays. Now I do want to point out one thing that we've been using in this course has been strings. So I've been creating character strings. So I could say like char phrase, and I could set this equal to Giraffe Academy. Or other times in the program, we created like, when we were making our little game, we created an arrays, and I would just say like 20, and then I would get input from the user and put that information in here. This is basically a string of characters. So anytime we create a string in C, like if I was to create a string over here, I called it like array or whatever, this is an array. So we've kind of just been taking this for granted. Like I've kind of just been calling this a string or calling it like a string of characters, but it's basically just an array of characters. The only difference is this is such a common thing to use in our programs that C makes it special and makes it really easy for us to create it. But just like that array of integers, this is also an array. So now you kind of have a better understanding of what strings are and what they're actually doing. In this tutorial, I'm going to talk to you guys about functions in C. Now, a function is basically just a collection of code that performs a specific task. So what you can do is you can take a bunch of code, maybe like 5 or 6 or 20 lines of code, and put it inside of a function. And then when you want to access that code that's inside the function, you can call the function. And generally, when you create a function, you'll design the function to perform a specific task. So the function will have a specific purpose. So I'm going to show you guys how to create functions, how to work with them, and we'll just talk about the basics of using functions. Like I said, a function is basically just a collection of code that does a specific task. So we can actually create a function here in our C program. Now you'll notice up here we have this block of code. It says int main, and there's an open and close parentheses and an open and close curly brackets. And we've kind of just been using this for the entire course. Like up to this point in the course, we've just been kind of using this main little block of code here. But actually, this is a function. And sometimes you'll hear people call this a method as well. So function and method are two words that essentially mean the same thing. But generally in C, we're going to refer to these as functions. But this is called the main function. And the main function is basically a function that's going to get executed when we start running our program. And so we've already been using a function, this main function, but if you want, we could actually create other functions in our program. So I'm going to show you guys how to do that. So let's go down, and we're going to go here outside of this function. And the way you can tell we're outside the function is we're outside of this ending curly bracket. So down here, I'm going to create a function. And when we create a function, we actually have to give C a couple pieces of information. The first thing we have to tell C is the return type of the function. And so actually we're going to talk more about return type in the next tutorial, but for now just know that return type is basically the type of data that the function is going to return to the user. So sometimes your function can actually give information back to whoever calls it. In our case though, we're just going to say void, and void basically means that this function isn't going to return any information. That's the first thing that you have to tell C. The second thing we have to do is give this function a name. And generally when we're naming a function, we're going to want to name the function according to what it does. So in our case, we're going to create a function that says hi to the user. So I'm just going to call this function say hi because that's what it's going to do. It's going to say hi. Whenever I create a function now, I want to make an open and closed parentheses, and I'm going to make an open and closed curly bracket. So now, any code that goes in between these curly brackets is going to be considered code that's inside of this function. So let me show you guys. I'm just going to make this a very simple function. We're going to do one thing inside of here. We're just going to make a printf, and we're going to print out hello user. So I've created my function. It's called say hi. And inside of this function, we're just printing out hello user. So now let's go ahead and run our program and see what happens. So I'm just going to build and run my program. But you'll see up here that hello user doesn't get printed out, right? In other words, I came down here, I said printf hello user, but this didn't get printed out. And this is the first lesson with functions, is that in order to use the code inside of the function, we have to call it. Calling a function basically means we're telling C that we want to execute all the code inside of it. So if I want to execute this code, I can call this function. And the way that I do that is just by typing out the name of the function and an open and close parentheses. So now, instead of just printing out nothing, C is actually going to go over here and execute all the code in the say hi function. So let's run our code, and you'll see now we're printing out hello user. So the difference between this main function up here and this say hi function is this main function is a very special function, right? When we run our program, this main function basically gets called. Then if we want to use other functions, we can call them from inside of this main function. And that's sort of how this is going to work. So also I want to show you guys one other thing. I just want to illustrate the flow that these functions take. I want to show you guys how these get executed by the program. So I'm printing out top and I'm printing out bottom, and I'm calling say hi right here. So now I'm going to run my program again, and you'll see we're printing out top, then we're printing out hello user, then we're printing out bottom. And this might have looked a little bit better if I put new lines, but essentially what's happening is when C goes to execute this program, it's going to execute this first line of code, printf, so it's going to print out top. Then we're telling C that we want to call the say hi function. C is now going to jump over here to the say hi function, and it's going to execute all of the code inside of here. So in this case, we just have one line of code, but I could put any number of lines of code inside this function. So if I had like 5 lines of code, it would execute all 5 of those lines of code. Then it's going to jump back up here, and it's going to move on to the next instruction. So that's kind of how that works. And that's sort of the basics of writing functions. Anytime you have a block of code or a bunch of code that does one thing, or that you want to kind of encapsulate into its own little container that you can call, you can put it inside of a function, and then whenever you want to access it, you just call it. But these functions can actually do a lot more. So one thing we can do is we can give these functions some information. So I can actually give this function a piece of information, and it can use that information to do different things. This is what's called a parameter. And a parameter is basically just a value that we give to a function. So let's say in this say hi function, instead of just saying hi to the user, we wanted to say hi to someone specifically. Well, I can actually come down here in these parentheses, and I can specify a function parameter. And I can specify a parameter a lot like I would specify a variable. So I could say, for example, char name and an open and closed square brackets. And basically what I'm saying down here is this say hi function is going to take as a parameter, in other words, as an input, a string of characters called name. And what I can do is I can come down here and I can actually print that out. So I could say %s, and we could print out name. Now, over here, when I call this say hi function, because I specified that it's going to take a parameter, I have to give it a string. So I could give this a string like Mike, like I'll put my name in here. When I call this say hi function now, I'm passing the value Mike into this function. So Mike is going to get stored inside of this name array, and we're going to be able to print it out down here. Let's go ahead and run our program, and you'll see it says hello Mike. So instead of saying hello user now, we're able to customize what it says. The cool thing about this is I could copy this line of code. Like I could call this function a bunch of times with different names. Actually, I'm going to put a new line down here so this is more obvious. So I could say hello Mike, hello Tom, hello Oscar. Now when I run my program, it's saying hello to each of these different people. And because we define the function and we can pass it different names, and depending on what we pass it, depending on the parameter that we give it, it'll perform its task a little bit differently. You can also specify multiple parameters. So let's say in addition to accepting the name as a parameter, we also accepted their age. So I could say char name, and then down here I can specify int age. And now we're basically saying that this is going to take an age as well. So I could say hello, and then I could say you are, and we'll say the age. So now over here, instead of, in addition to just saying name, we can also say age. So now when I run this function and when I call it, I have to also give this an age. So we could say like 40, 23, and 70. And now this is going to print out all of that information for us. So hello Mike, you are 40. Hello Tom, you're 23. Hello Oscar, you're 70. And you can pass as many parameters as you want into one of these functions. You always just have to make sure though that you're passing a parameter when you're calling the function, just like that. So that's the basics of using functions, and in the next tutorial we're going to talk about this guy over here, which is the return type, and we're going to look at how we can get information back from a function. In this tutorial, I want to talk to you guys about return statements in C. A return statement is a special line of code that we can include in our functions, which will allow them to return information back to whoever called them. So I can write a function and then I can have that function give information back to whoever called it. That could be information like the result of some operation, or it could be a message telling whoever called it how the function went. It could be anything like that. So I'm going to show you guys basically how we can do that, and I'll just give you an overview of like return types and all that stuff. So down here, I'm actually going to create a function, and we're going to create a function that cubes a number. So when you cube a number, generally you take it to the third power. So I could say like 2 raised to the third power, which is the same as just saying 2 times 2 times 2. This would be cubing a number, right? You're taking it to the third power. So I'm going to make a function that's going to do that. Basically, this function will accept one parameter, which is going to be a number, and it'll cube that number. And then once it's done cubing the number, it'll give that value back to the caller. And you guys will see how that'll work. So I do want to point out one thing. Whenever we are returning values in our function, so if you're going to write a function that's going to return a value, you always want to put it above the function that's going to be calling it. So for example, like this main function down here, this is the first function that executes. So any code we put in here is going to get executed first. If I want to return a value with my function, I'm going to define the function here above the main method. And there's a couple reasons why we want to do that. Essentially, it'll just make sure that everything works correctly. So we want to make sure that we define this function before we actually call it down here and get a value back. So the first thing that I need to tell C when I want to create a function is what type of data I want to return. If you've been following along with this course, you'll know in the last tutorial we used the void return type, which basically means we weren't going to return any information. But now we want to actually return information, right? So we want to cube a number, so why don't we return a double? And you can put any data type here you want. You could also put like int or a character or a character array. But let's just do double, and we're going to give this a name. So I'm going to call this cube, and I'm going to make an open and closed parentheses. And inside of this parentheses, we're going to allow this method, or we're going to allow this function to accept one parameter as input. So it's just going to be another double, and we'll call it num. So basically what we want to do is we want to cube num, and we want to give that value back to the user. So over here, I'm just going to create a variable. It's just going to be another double called result. And I'm going to set it equal to num times num times num. So basically this variable result now represents or now stores the cubed value of num. All we need to do to return this value now is just say return result. And this return keyword is basically going to do a couple things. The first thing it does is it breaks us out of the function. So wherever we put that return keyword, it's going to break us out of the function, and it's going to return this value back to the caller. So down here, we can actually call this function. So actually what I want to do is I want to print out the answer that we get back. So I can do printf, and in here I'm just going to say answer, and we'll print out the answer. So %f. So I'm using %f because we're expecting to get a double back from here. Remember, double is the return type. And over here, I can just say cube, and we'll pass in a number. Let's pass in 3.0. Essentially, what's going to happen now is we're going to call this function. All this code's going to execute, and this function is going to get a value back, basically the value of cubing 3.0. So normally, like in the past in this course, when we wanted to print out a number, we'd have to put like 4 or 76 or whatever. We'd have to put a number right there. But we can just call this function because eventually this is going to get a number back anyway. So this will contain a number after the function's done being called. So I can actually just run my program now, and this is going to print out the result of cubing 3.0. So you'll see down here we get 27.0000. So 3 cubed is 27. 3 times 3 is 9. 9 times 3, 27. So looks like our cube function works. Let's try it with another number. Why don't we do 7? So let's run this again, and we get 343. I'm guessing that's right. So basically what we did is we created this function, and we used this return keyword, and we returned back to the caller the value of cubing the number. And that's really cool. And actually, so we can make this a lot simpler. So I could actually just get rid of this result variable, and I could just straight up return num cubed, and this is going to do the same exact thing. So we should get the same answer. Yeah. So this can be really awesome. And one thing I want to point out is this return keyword will actually break us out of the function. So if I came down here and I said like printf, and I printed out like here, this code is actually never going to get executed. So if I was to run my program, you'll notice that it's not printing out here. So that never gets printed out. In other words, this line of code down here, printf here, this never gets touched. Because when we use this return keyword, this breaks us out of the function. So whenever C sees this return keyword, it just exits the function and goes back down here to the normal program. So just keep in mind that you can't really put any code after you use this return keyword because it will break you out of the function. And I actually want to talk to you guys about one more thing really quick. You'll notice up here I'm creating my cube function above the main function. So I actually created this above here. And the reason that I did that was because if I was to move this down here below the main function, and I try to run my program, you'll notice that we're getting an error over here. And actually, if we look at the error down here in the output, it says error conflicting types for cube. Now, essentially what's happening is when I create this function down here below this main method, when the main method over here tries to call it, it actually doesn't know about this function yet. Like it doesn't necessarily know like what this function is, what it's going to return, and what parameters it's going to take because we created it after we created this main method. So what I can do is actually something called prototyping. And when I prototype, it'll allow me to create this function below this main function without getting this error. And basically when you prototype, I'm basically just going to write out the function signature. So we would call this like the signature, basically the return type and the parameters and the name. So if I was to put this up here and put a semicolon, now when I run my program, you'll see that we're not getting this error anymore and we're actually getting the answer back. So this is a way that you can create functions below that main function without having any problems. And basically any functions that I created, I could put another prototype up there at the top and it's gonna be fine. In this tutorial, I'm going to talk to you guys about if statements in C. Now, an if statement is a programming structure which we can use to help our programs to make decisions. So by using an if statement, our programs can actually respond. So in certain circumstances, they can do certain things, and in other circumstances, they can do other things. And if statements are extremely powerful, and they're a great way to add some intelligence to our programs. For the purposes of this tutorial, we're going to be building a function. So we're going to build a function, and it's going to be called the max function. And basically what this function is going to do is it's going to take two parameters, two numbers, and it's going to tell us which number is the biggest. So I could give it like 4 and I could give it a 10, and it'll tell us which number is bigger. Let's go ahead and do that. I'm going to make this function up here, and it's going to return an integer, and I'm just going to call it max. And it's going to take as parameters two integers. So it's going to take an integer num1, and it's going to take another integer num2. And now we'll just make the actual function body. So inside this function, our job is to figure out whether num1 is the biggest or num2 is the biggest. And we're going to return the biggest to the caller. So the first thing I'm going to do is create a variable, and it's going to be an integer, and I'm just going to call it result. And I'm not going to give it a value right away. And what we need to do in this function is we need to figure out which one's bigger. We need to figure out if num1 is the biggest, or we need to figure out if num2 is the biggest. And this is a perfect situation to use an if statement. An if statement allows us to check a certain condition, and if that condition's true, we can do one thing, and if the condition's false, we can do another thing. So down here, I'm going to use an if statement. I'm basically just going to say if, and then we're going to make an open and closed parentheses, and I'm going to make an open and closed curly bracket. Now, inside of here, inside of these parentheses, we need to specify a condition. This is something that's either going to be true or false. If the condition inside of these parentheses is true, we're going to execute the code inside of these curly brackets. If it's false, then we're just going to move on. So in order to tell whether or not num1 is bigger than num2 or num2 is bigger than num1, we can actually compare them. So down here, I could say if num1, and I can use this greater than sign, num2. I'm basically saying if num1 is greater than num2, then I want to do something. So down here, we can set result equal to num1. If this condition's true, then we're going to do this. So only when num1 is greater than num2 are we going to set result equal to num1. So basically by using this if statement, we're able to tell which one is bigger. But here's the thing, what if num1 isn't greater than num2? What if num2 is greater than num1? Well, I can use something called an else statement. So I could come down here and I could say else, and I don't actually need to use an open and close parentheses. I can just make an open and close curly bracket, and the code inside of this else block is going to execute if the condition up here is false. So if this condition is false, if num1 is not greater than num2, then we can just set result equal to num2. And then down here, finally, we're going to return result. So depending on whether or not this is true, result is either going to set equal to num1 or it's going to be set equal to num2. So let's go down here into our main method, and why don't we call this? So I'm actually going to print out the result. So I'm just going to say printf, and we're going to be printing out an integer. And over here, I'm going to call this function. So I'm just going to say max, and I'm going to pass in two numbers. So we're passing a 4 and we'll pass in a 10. So I'm passing in a 4 and I'm passing in a 10, and this is going to return to us whichever one is bigger. In other words, this should return 10. So let's go ahead and run our program. And you'll see over here we're returning 10. So we got the value of 10 back from this function. Let's try it with the other numbers. So let's make the first number bigger. So now we have 40 and 10. So this should give us 40 back. Awesome. So over here we have an awesome function, right? We're basically checking to see if num1's greater than num2. If it is, then we're going to return num1. Otherwise, we're going to return num2. And it's important to note that even if I made these equal, so if I made it 40 and 40, we're still going to get back the correct answer. So it's still going to give us 40 back. So this is the basics of using if statements, right? We say if we specify a condition, if that condition's true, we're going to execute this code. If that condition's false, we're going to execute this code down here. And that is an extremely powerful structure in our programs. And we can really use this to respond to different input, right? So depending on what the user puts in num1 and num2, we can do different things. But this is just sort of the beginning, so why don't we try to make this function a little bit more complex. So down here, we're allowing the user to input 2 parameters, so we're accepting 2 parameters into this max function, num1 and num2, and we're able to spit out which one is bigger. But let's up the ante a little bit. What if we wanted to accept 3 parameters? So instead of just passing in 2 numbers, we wanted to be able to pass in 3 numbers and have the max function spit out the biggest. So over here, we can modify this max function. So I'm just gonna make another parameter. So I'm gonna say int, and we'll call this one num3. So now this function is accepting 3 parameters, num1, num2, and num3. But in order to figure out which one of these is the biggest, we're actually gonna need a more complex if statement. So I'm gonna get rid of this, and let's just start from scratch. So let's think about this. How can we figure out which one of these is the biggest? Well, what I would recommend is we could say if num1 is greater than num2 and num1 is greater than num3, then we know num1's the biggest, right? So if num1's bigger than num2 and it's bigger than num3, we know it's the biggest. If num2 is greater than num1 and num2 is greater than num3, then we know num2 is the biggest. And otherwise, we can just say that num3 is the biggest. So I'm going to show you guys how to do this, and we're actually going to be introducing a couple more concepts for if statements. So I'm just going to say if, and I want to check a condition. So I basically want to see if num1 is greater than or equal to num2 and num3. So down here I can say num1 is greater than or equal to num2. And now I also want to check to see if num1 is greater than or equal to num3. Because if num1 is greater than or equal to num2 and it's greater than or equal to num3, we know num1 is the biggest. So I can use this special signal here. This is called a logical operator and basically this is going to allow us to put another condition in here. So I could say num1 is greater than or equal to num3. Basically what this and does is it allows us to put 2 conditions so we can check 2 things, and this whole thing is only going to be true if this condition's true and this condition's true. So if one of these guys is false, then this if statement isn't going to get executed. So down here, I'm just going to open this up, and if this is the case, then we want to set result equal to num1, because if num1's greater than or equal to num2 and num1 is also greater than or equal to num3, then we know num1's the biggest. But here's the thing, we also want to check to see if num2 is the biggest. So if this is false, we also want to check to see if num2 is the biggest now. And we can use something called else if. So down here I could type out else if, and I can make another open and closed parentheses. And inside of these parentheses, we can actually check another condition. So if this stuff up here, if this condition's false, then else if is saying, let's come down here, let's check another condition. So here I want to do basically the same thing. I'm going to check to see if num2 is greater than or equal to num1 and num2 is greater than or equal to num3. So if this condition is true, if num2 is greater than or equal to num1 and it's greater than or equal to num3, then we know for a fact that result is going to be num2 because that's the biggest. Now finally down here we can just say else, and we can make another open and close curly bracket. And remember, this code is going to get executed when neither of these conditions is true. So here we can just set result equal to num3. So let me walk you guys through this one more time. Up here we have this if statement. And in addition to checking to see if num1 is greater than or equal to num2, we're also using this special operator called and we're checking to see if num1 is greater than or equal to num3. If that's the case, then result is going to be equal to num1. Otherwise, if this condition is false, then we're going to come down here and we're going to check this other condition. So we're going to check to see if num2 is bigger than num1 and if it's bigger than num3. If that's true, then we're going to do this. Finally, if neither of these conditions up here is true, we're just going to go ahead and set result equal to num3. And then we're going to return result. So this looks good to me. Let's test this out and we're going to see if it works. So now when we call max, we need to include 3 numbers. So why don't we just do 1, 2, and 3. And this is basically going to spit out the biggest one, which should be 3. So let's run our program. And you can see over here we get 3. So let's try to make one of the other ones the biggest. So we'll make the one in the first slot the biggest. And let's run this again. and you can see that it returns 10. So this function is working. So that's how we can use these ands, and we can also use else if in order to check additional conditions. So the and is used to check more than one condition inside of the if parentheses, and the else if is used to check another condition when this condition's false. And so that is actually going to work out pretty well. Now, I want to show you guys a couple other things. There's a couple other things that we can do with these if statements. So for example, I'm going to come down here and just show you guys some of these. In addition to using that and, we can also use something called or. So I'm just going to type out a simple if statement. I could say if 3 is greater than 2, and instead of using and like this, I can use or. An or is basically going to allow us to check two conditions, and the whole thing is going to be true if only one of those conditions is true. So I could say if 3 is greater than 2 or 2 is greater than 5. So only one of these is true, right? 3 is greater than 2, that's true, but 2 is not greater than 5. So this guy's false. But when we use or, only one of these two conditions has to be true for the whole thing to be true. So if I like printed something out here, like true, now when I run my program, we should print true because we're using that or, and you see that we do. But if I was to make this guy false, so if I made this 3 less than 2, now it's not going to print out true, and we can just print out false. So now we're going to end up printing out false because both of these guys are false. So you can see down here we're saying false. So the difference between and or, when we have and like this, both of these conditions have to be true in order for the whole thing to be true and for us to execute this code. When we have or, only one of these guys has to be true. So that's kind of the difference there. And I want to show you guys a couple other things that we can use. So over here, we're using like a less than sign. So for example, if 3 is less than 2, I could also use a greater than sign. I could use a less than or equal to sign. I could use also a greater than or equal to sign. And if I wanted to check for equality, I could use a double equals. So the double equals will check to see if 3 is equal to 2. We can also use one more, which is this exclamation point. An exclamation point basically means not equals. So I could say if 3 is not equal to 2, then we'll print out true. So down here, let's run this and you'll see that we get true. So yeah, there you go. One more thing I want to show you is how we can negate an entire operation. So for example, if I said 3 is greater than 2, this is going to be true, right? So we'd end up printing out true down here because 3 is greater than 2. But I could surround this whole thing with parentheses, and I could put an exclamation point right before this, and this is called the negation operator, and it's basically going to negate whatever this ends up being. So if this is true, and we put this negation operator here, this whole thing is going to be false. And so now you'll see, because this is true and we're using the negation operator, we're not going to end up printing out true. And you can see we just don't print anything. But if I put a false condition in here, like if I said 3 is less than 2, this is false, but because we're negating it, now it's going to end up being true. So when I run my program, you can see that we get true. So that's sort of the basics of using if statements. And I covered just about everything that you can do. We can use ands, we can use all these different comparison operators, we can use ors, and we can use this exclamation point to negate something. In this tutorial, I'm going to teach you guys how to build a calculator in C. If you've been following along with this course, you'll know that in the beginning of the course, we actually created a calculator, and it was a very basic calculator. Basically, we let the user input 2 numbers, and we took those numbers, we added them together, and we printed the answer out onto the screen. In this tutorial, I'm going to take some of the stuff that we've learned since then and show you guys how we can build a fully functional 4-function calculator. So this calculator will be able to add, subtract, multiply, and divide, and we're going to let the user decide which one they want to do. So we'll let them decide if they want to add or subtract or whatever. It's going to be pretty cool, and we're going to end up using some of the stuff that we've learned recently in the course, like if statements. We're also going to use like getting input from users, and I'm going to show you guys how you can get characters as input from a user as well. So down here, we want to start making our calculator. Basically what I'm going to do is I'm going to ask the user to enter a number, then I'm going to ask them to enter an operator like plus, minus, division, or subtraction, Finally, we're going to ask them to enter in a third number, and then we'll, depending on what operator they specify, so addition, subtraction, whatever, we will perform the correct operation and we'll print out the number. So the first thing I want to do is create variables where we can store the numbers and the operator. So I'm going to make some double variables, and I'm just going to call this one num1, and then we'll make another double, we'll call it num2. And finally, we'll make a variable that will store the operator that they enter. So this is just going to be a char, and I'm just going to call it OP for operator. All right, so now we want to actually get input from the user. I want to figure out what numbers they want to use and then what operator they want to use as well. So down here, why don't we get some input? The first thing I'm going to do is I'm just going to print out a prompt. So I'm just going to say enter a number. And now what we want to do is we want to be able to take the number that they give us and store it inside of one of those doubles that we created. So I'm just going to use this scanf function, scanf, and in here I'm going to specify that we want to get a double. So remember, when we're using scanf, if we want to scan for a double, we use lf. And lf is going to scan for a double. And now I'm going to use a comma, and we'll put the variable that we want to store in here. So I'm going to use this ampersand, and I'm just going to say num1. So this is exactly what we need to do to be able to get the user's input and store it into num1. The next thing we want to do is get the operator. So I'm going to type out another prompt, and I'm just going to say enter operator. Basically, they'll be entering in plus sign, minus sign, asterisk, or forward slash, depending on what they want to do. And again, now we're going to scan for a character. Now, when we're scanning for a character in scanf, and I actually don't think I've talked about this yet in this course, we want to do something special. So I want to put a % in a C, but before I put %C, I want to put a space. So whenever we're getting a character from the user using scanf, we always want to put a space right here before %C. Otherwise, it's not going to work. And again, we want to store this in that OP variable. So I'm just going to say OP. And one more time, we're going to get another number. So I'm just going to copy this. We'll paste this down here. And we're going to get this one for num2. So now we should have all of the input for our program. So I'm getting the first number, I'm getting the operator, and I'm getting the second number. The last thing we have to do now is actually do the math. So we're going to have to figure out which operator they wanted to use, right? So we have this OP variable. And this is storing like a plus sign, a minus sign, a asterisk, or a forward slash. So depending on what that's storing, we want to print something different out. So we can actually use an if statement to do this. So I can use an if statement to check and see what operator is inside of our operator variable. And depending on which one it is, we can do a different operation. So I can say if, and the first thing I'm going to do is just check to see if the operator is equal to a plus sign. So if the operator that the user entered is equal to a plus sign, then we're going to want to add the two numbers together. So I'm just going to print out these two numbers, and I'll just say num1 plus num2 because we're going to add both of them together. We can also use an else if, so I'm going to want to check a few other conditions. I'm going to check to see if the operator is equal to a minus sign. And if the operator is equal to a minus sign, then instead of adding the numbers, we're going to subtract them. So over here, I'll just copy this and we'll paste this guy down here. So it's going to be num1 minus num2. And I can actually just copy this whole thing and we'll paste it down here. So let me make some more room. Down here, we'll paste this other else if. And here we're going to check to see if it's division. So we'll check for a forward slash. And again, we're just going to want to print out a decimal number. So it's going to be num1 divided by num2. And finally, we're going to check for multiplication. So if it's multiplication, then we're going to multiply them together. So now we're checking for each of the operators. We're checking for addition, subtraction, multiplication, and division. But here's the thing. What happens if the user enters in an operator that we didn't want? So for example, if they don't enter in any of these operators, we're going to want to tell them. So I'm going to have this like print out a little error message. I'm just going to say else. And basically the code inside this else block will get executed if none of these conditions up here are true. And down here we can just make a printf. And I'm just going to print out invalid operator. So now we have our if statement, our if block set up, and this should be everything that we need to use our little calculator. All right, so let's go ahead and run this program. So you can see over here it says enter a number, so we can enter a number. Let's enter in 5.9, and enter an operator. We'll add numbers, and now let's enter in 4.0. So we're going to add 5.9 and 4. So when I click enter, we should go through all of those if statements and figure out what we need to do. And you'll see over here that we're adding 5.9 and 4 together, and we're getting 9.9. So looks like the program worked. Let's try it again. We'll try another operator. Why don't we try to multiply some numbers? So let's multiply 6 and times, I don't know, 5.7. So we get 34.2. That seems about right. All right, and then one more time we'll run this, and I want to try to enter in an invalid operator. So we'll say like 5.7, and I'm just going to enter in a G. So that's an invalid operator. That's not going to work. And I'll enter my number. Let's do 8, and you can see it tells us invalid operator. So basically we have a 4-function calculator. This calculator can multiply, divide, subtract, and add. And if you don't enter in a correct operator, it's smart enough to yell at you and tell you that you have an invalid operator. So this seems to work pretty well. I'm pretty happy with it. And you can see down here, like, this is a perfect situation for using something like an if statement, right? We have this variable OP, right? It's storing some sort of operator. We don't necessarily know what's inside of there, but I can use if statements and I can respond to the different scenarios. So in the situation where it's a plus sign, I can respond. In the situation where it's a minus sign, I can respond, etc. And this just makes our programs a lot smarter, and it helps us to do different things when different situations arise. In this tutorial, I want to talk to you guys about using switch statements in C. Now, a switch statement is basically a special type of if statement which will allow us to compare one value to a bunch of different values. And it's essentially doing the same thing as an if statement. It's allowing us to check different conditions, and if different conditions are true, then we can do certain things. But a switch statement makes it really, really easy for us to compare one specific value to a bunch of other values. And I'm going to show you guys how we can use that in this tutorial to make a little test app. So I'm going to build a little program that will take a letter grade, and depending on the letter grade, it will tell you whether or not you did good or bad on a test. So if you got an A on the test, it would say, hey, you did a good job. If you got a B on a test, it'd be like, hey, you did all right. If you got an F on a test, it'd tell you that you failed the test. So we're basically going to have a variable where we'll store a grade that you would have gotten on a test, and we'll be able to respond to that grade using a switch statement. So it's going to be pretty cool. So down here, the first thing I'm going to do is create a variable, and it's just going to be a character, and I'm just going to call it grade, and I'm going to set it equal to A. So we're going to say that whoever took this test got an A on the test and they did really well. Now what I want to do is I want to create a switch statement. So I'm just going to say switch, and I'm going to make an open and close parentheses. And inside of this parentheses, I'm going to put grade. So I'm just going to put grade, and I'm going to make an open and close curly bracket. So this is sort of like the basic structure for our switch statement. Now, here's what I'm basically going to do. I'm going to take this variable here that I passed into the parentheses, grade, and I'm going to compare it to a bunch of different values. So I'm going to take this and I'm going to see if it's equal to one value, then I'm going to see if it's equal to a different value or a different value or a different value. And depending on the value that it ends up being equal to, we're going to do something different. And these are what are called cases. So down here I can say case, and I just want to type out a character. So for example, I could put A right here, and then I'm going to put a colon. And when I put A right here, basically what this is saying is in the case that grade is equal to A, then I'm going to put some code down here that I want to execute. So I could just put like a print statement, and I could say like, you did great, because they did great on the test. And basically what this is saying is in the case that the grade is equal to A, we're going to print this out, and then I want to put one more thing down here, which is called break. And I'm going to explain what break does in a second. So I could make one of these little case statements for every possibility. So for every possible grade that we could get. So I'm actually just going to copy this whole thing, and I'm going to paste it down here. So now I can put a B in here. So we're saying in the case that the grade is equal to B, I'm going to say you did all right. And then we're also going to break. And down here, I'm going to make another one. So I'll say case, and this time we'll make it C. In the case that they get a C, I'm going to print out poorly. And there's a couple more that we can check. So we can check if they got a D or an F. So in the case They got a D. And I forgot to put a break statement here. And I'm gonna put one down here too. And finally, we're just gonna do one more for if they failed the test. So I'm just gonna say in the case that they got an F, we will print out you failed. So essentially what I'm doing here is I'm writing out all of these different cases. So I'm saying in the case that you got an F, I'm gonna print out you failed. In the case they got a D, I'm gonna print out you did very bad. And then we also have this break statement here. And this break statement basically tells our switch statement that we wanna leave. So whenever we're executing this switch statement, whenever C is executing this switch statement, it's checking to see if grade is equal to each one of these cases. So for example, let's say the grade is equal to A, it's gonna execute this print F, but if I don't put this break statement in here, then it's just gonna keep going and keep checking these different cases. So it's always important to put a break statement in there because I basically just wanna break out of this switch statement. I don't wanna be in here anymore. So finally, we can check one more thing. In the case that the user or that we get an invalid grade. So for example, if someone entered in like a T or a G or something, that's not a valid grade. So I can use something called default. And default is basically like an else. So default is going to execute whenever none of these conditions up here are met. So then I can just put something like invalid grade or something. And this will basically be like, hey, you got an invalid grade. So let's take a look at this switch statement and we'll just kind of talk a little bit more about what it's doing. Basically, I'm passing this in a variable or a value or something, and I'm gonna check this value against all of these different conditions. So in the case that grade is equal to A, we're gonna print you did great. In the case that B is equal to grade, we'll print you did all right, etc. And this is basically doing what an if statement's doing. So I could replicate this entire statement, this entire switch statement as an if statement. I could write out if, etc., else if, else if, else if. But this just makes it a lot easier so I don't have to constantly write out all of that if statement stuff. So hopefully we did everything right, and let's actually check and see how our program does. So grade is equal to A. Let's run our program and see what our message is. It says, hey, you did great because we got an A. If I made this an F instead of an A, now it should tell us that we failed. So it says, you failed. If I made this a C, it'll tell us that we did poorly. And it says, you did poorly. So this is a super easy way for us to check one single value against a bunch of different conditions. And that's really the point of a switch statement, is you're checking one single value, like grade, against a bunch of other values. And that's where it can be extremely useful. So consider using these switch statements. They're not appropriate in every situation. And there's, I'd say, like very select few situations where switch statements will come in handy. But when they are appropriate, switch statements will save you a lot of time and a lot of hassle. In this tutorial, I want to talk to you guys about structs in C. Now, a struct is a data structure where we can store groups of data types. So inside of a struct, I could store like an integer alongside of a string, alongside a character, alongside a double. I could store all these different data types in one single data structure. And there's tons of uses for structs. And one of the things we can do with them is model real world entities. So I could basically like model something in the real world inside of my program. And I'm going to show you guys how to do that in this tutorial. We're going to be looking at how we can use a struct to represent a student inside of our program. So imagine we were writing a piece of software that was using like students. So it was like storing records of students or something. I could use a struct to represent a student in my program. So over here in my program, I'm just going to come up here above the main method, and I'm actually going to create a struct. You guys will see like how these work and how we can use them. So I'm just going to say struct, and over here I'm going to give this a name. So I'm going to call this student. And a lot of times in C, when we're making structs, you're going to give them a capital letter just like that. And I'm going to make an open and closed curly bracket. Now, inside of this struct, I can start specifying what types of data are going to make up a student in my program. So basically I can define like different attributes of a student and place them in here. And this will kind of act as a template, and you'll see how we can use this later. So let's think about different attributes of a student. Well, one thing would be like the student's name. So I could say char name and I'm going to make this a array of characters. So this is going to represent the name. And actually, why don't we give this a number? So I'm going to say 50. So this string can hold 50 characters maximum. And now we're going to make another one for major. So we're going to want to store the student's major. And again, we'll make this 50. I also want to make an integer for the student's age and a double for the student's GPA. So I have this struct student, and in here I have a bunch of attributes of a student, right? I have like the student's name, their major, an integer that stores their age, and a double for their GPA. Essentially what I did was I created like a type of student data type. So I basically am allowing myself now to represent a student inside of my program. So let's come down here to this main method and I'll show you guys how we can use this. So I can basically create an instance of this student structure. So I can create like an actual student inside of my program. And the way that I do that is just by saying struct, and I want to type out the name of the struct that I want to make. In our case, it's going to be a student, and I want to give this a name. So I'm just going to call it student1. And I can just use a semicolon here. Basically what I did now was I created a container called student1 that's going to be able to store a name, a major, an age, and a GPA. So if you're familiar with arrays in C, you'll know an array is a special structure that can hold multiple pieces of information, but all of the pieces of information inside of an array need to be of the same data type, and also they don't have names. With a struct, I can have a bunch of different data types like this, and I can also give them names like name, major, age, and GPA. So now let me show you guys how we can assign some values to these. So for this particular student, student1, I can give them a name, I can give them a major, a GPA, and an age. So I could say student1.age, and I can set this equal to something. So I could say, let's say student1's age is 22. So basically inside of this student1 container, I'm saying the age of this particular student is going to be 22. I can do the same for the GPA. So I could say student.GPA is equal to, maybe they have a 3.2. So I'm saying this particular student's GPA is a 3.2. I can also do the same thing for those strings. So for the name and the major. Now, here's the thing about working with strings. Remember in C, a string is actually just an array of characters. And when we have an array, we can't like give it a particular value. So for example, if I wanted to give this student's name a value, this is just an array of characters. So I can't just come down here and say student.name is equal to something. That's not going to work because you can't do that with an array. I can use something called the string copy function. And this is a function that will take a string and it'll give it a value that we specify. So it'll basically do what we want to do, like what we did over here with the age and the GPA, but with the name. So I could say like strcpy, and inside of here I need to pass this two parameters. The first thing I want to pass is the destination for the string. So we're going to pass in student1.name. The second thing I want to pass in is the string that I want to store inside of student1.name. So in our case, let's just name him Jim. So now we have the student1.name's value is equal to Jim, and I can do the same thing for major. So I'm just going to copy this and we'll come down here and I could say student1.major, and we're going to set this equal to business. So let's say Jim is a business major. Essentially what I've done here is I've created a student, and that student had all the attributes that we defined up here. So this particular student had a name, a major, an age, and a GPA. And I gave all of those values. So I assigned this student 1 an age of 22, a GPA of 3.2, etc. So now what I can actually do is I could print out all of these different values that are stored inside of this structure. So if I wanted, for example, I could like print out the GPA. So I could print out student1.GPA, and now we're going to be printing out 3.2. And actually, it looks like I have a typo here. This should be student1, not student. All right, so here we're printing out 3.2, so we're printing out the value of the student's GPA. I could also print out like their name, so why don't we do that? Student1.name, and now this is going to print out Jim. So you see we print it out over there. So a struct is a really useful structure. And another cool thing we can do with structs is we could actually create another student. So I could create like another instance of that student structure. So I'm actually just going to copy all this stuff. I'll show you how we can do this. I'll just come down here and paste it. And instead of student 1, why don't we call this one student 2? And we can set this student's age to be like maybe 20. Maybe their GPA is a 2.5. Let's say their name is Pam and they're studying art. So now I have a completely different student, and if I wanted, I could print out this student's attributes. So I could print out like student2.name, and now we're going to get Pam instead of Jim. So you can see how that works right there. So I could create as many of these students as I want, and this is what's cool about structs, is I can just define the basic template for a student in my program, and then I can create individual students down here that I can work with. So now I have this like student variable here. I could do whatever I want with it. I could pass it into a function. I could print it out onto the screen. I could use it in something like an if statement. I could do basically anything I want with it. It acts a lot like a variable or an array. So remember, variables and arrays are just containers. And we can do just about anything we want with them. And that's the same with a struct. So this has just been kind of an introduction, and what you could do as an exercise is think of other things you might want to model in your program. So maybe something like a book or something like a phone. You could model a phone using a struct. Basically any type of information you could store using a struct just like this. In this tutorial, I want to talk to you guys about while loops in C. Now, a while loop is basically a structure in the C programming language that we can use to loop over and continually execute a specific block of code until a certain condition is false. So I can specify a condition, and then I can basically just loop over a bunch of code until that condition is no longer true. And loops can be really useful. There's a lot of times in our programs where we're going to want to like continually do something while something else is true or while a certain condition is met. And I'm going to show you guys a really basic while loop in this tutorial, and then in the next tutorial we're actually going to build a really cool guessing game using while loops. So it should be pretty fun, and you should get a pretty good idea of like how these things work. The first thing I want to do, and this isn't directly related to creating a while loop though, is I want to create an integer. So I'm just going to create an integer called index, and I'm going to set it equal to 1. Now what I want to do is I want to actually create a while loop, and you guys will see where this index comes into play. So in order to create a while loop, I can just type out while, an open and close parentheses, and then an open and close curly bracket. And this is basically like the outline, sort of like the template for our while loop. Basically how this is going to work is up here in these parentheses, I'm going to specify a condition. And as long as that condition is true, I'm going to loop through all of the code inside of these curly brackets. So inside of these curly brackets, I'm going to put a bunch of code, and as long as the condition in these parentheses is true, I'm going to execute all that code. So up here, we're going to specify a condition. I'm going to specify a condition that index is less than or equal to 5. So while index is less than or equal to 5, I want to execute all the code inside of here. So I'm going to put some code in here. The first thing I'm going to do is I'm just going to print out the value of index. So over here, I'm just going to say we want to print out an integer, and I'm just going to print out index. So we'll be printing out index, and actually, why don't we print out a new line every time too? There we go. And finally, after this, I want to increment the index variable. So I can just say index is equal to index plus 1. Basically, I'm adding 1 onto the index every time. And actually, I want to show you guys something in C. There's going to be a lot of situations where you're going to want to do something like this. Basically, add 1 to an existing variable. And in C, there's actually a shortcut we can use. So I can come over here and I can just say index plus plus, and this is going to do the same thing. So this is just going to add 1 to the index. Essentially what I'm doing is I'm saying I want to print out index, and then I want to increment index. And I'm going to keep looping through this code while index is less than or equal to 5. So let's go ahead and run this program, and maybe you can predict what's going to happen. You'll see over here I'm printing out the numbers 1 through 5. So I'm printing out 1, 2, 3, 4, and 5. And let me walk you guys through exactly what's happening in this loop. Over here, we create this index variable and we set it equal to 1. And basically when C goes to execute this program, the first thing it's going to do before it does anything else is it's going to look at this condition, and it's going to check the condition. And it's going to say, okay, is index less than or equal to 5? Well, the first time through, index is equal to 1. So it's definitely less than 5. C is going to go through, it's going to execute this line of code, printing out 1. Then it's going to execute this line of code, incrementing index. Then what C is going to do is it's going to come all the way back up here, and it's going to check this condition again. So it's going to say, okay, is index less than or equal to 5? And index at this point is equal to 2, so it's less than 5. So it's going to go through, execute this line of code, execute this line of code. Now index is equal to 3, and C is going to go all the way back up to the top. It's going to check this condition again. So before C goes through this loop, it's always going to check the condition first. So before it's allowed to go and execute that code again, it has to check the condition to make sure that it's true. Eventually, we're going to get to a situation where index gets incremented, and it gets incremented up to 6. Then C is going to come back up here, and it's going to check to see if 6 is less than or equal to 5. It's going to be false, and we're going to move on with our lives in the program. And that's the basics of while loops. So this seems very simple, and that's because it is. All we do is specify a condition. As long as that condition's true, we keep doing all this stuff in here. And there's tons of situations where while loops are going to come in handy. This is just one of them where we can print out like numbers between 1 and 5. I also do want to point out one thing that you might want to watch out for, which is called an infinite loop. And an infinite loop is a situation where this condition up here never becomes false. So this condition will just always stay true. And there's certain circumstances where you're going to want to use something like an infinite loop, but in a lot of circumstances, you're not going to want to go anywhere near something like that. So let me just demonstrate so you guys can see. So if I stopped incrementing this, if I just got rid of index plus plus, now when I run my program, you'll see that it's just continually printing out ones. I mean, look at all these ones that are getting printed out. You can see like the text editor is kind of going crazy. This program is just, it keeps executing through that loop, and it's still going right now. So this would keep going forever if I let it, keep going infinitely, hence the name. So I'm just going to terminate this, but that'll kind of show you like how an infinite loop works, and you definitely want to watch out for that because you'll get into situations as you work with while loops where they'll just become infinite, and you need to watch out for that, especially if you're doing something a little bit more advanced where you're like siphoning off memory or you're creating processes or something. It can slow your computer down quite a bit. So this is a while loop, and this is a really great loop. There's also one other type of loop that's similar to a while loop that I want to talk to you guys about. And before I do that, I just want to do something really quick. So I'm going to set this index equal to 6. Right? I'm going to set this equal to 6, and I'm going to run my program. And what you're going to notice is nothing's going to get printed out. So the code inside of this while loop isn't going to print out because the first thing we always do when we run this while loop is we check this condition. So the first thing C is going to do, before it prints anything, before it increments anything, it's going to check this condition. And if it's false, it's not going to do any of this stuff. So when I run this program, you'll see nothing's going to get printed out. And that's exactly what happens. There's another type of loop that's similar to a while loop, which is called a do while loop. And I'm going to show you how to make one. All you have to do is take this while thing up here and paste it down here below. And then up here, I'm just going to say do. And a do while loop is similar to a while loop, but the first thing a do while loop does, instead of checking this condition down here, is it executes all of this code. So even though index is equal to 6, we're still going to print out 6, and we're still going to increment it. And then we're going to check the condition to see if we can keep looping. So let me show you guys this, and this should illustrate what this is doing. And actually, I need to put a semicolon here. So you can see over here, we're printing out 6. So unlike before when we just used that while loop, now because we're using a do while loop, we're doing whatever was inside of that loop before we're checking the condition. And there's going to be certain circumstances where a do while loop will come in handy. I would say by far while loops are way more common. But just, it's good to know about do while loops because there are certain circumstances where they'll come in handy. Basically, anytime you don't want to be checking the condition first, you can use a do while loop. But those are the two basic types, and there's actually another type of loop that we'll talk about later in the course, which is called a for loop. But for now, we're going to have some fun with while loops, and in the next tutorial, we're going to be building a little guessing game. In this tutorial, I'm going to teach you guys how to build a little guessing game in C. This is going to be pretty cool because we're going to use a lot of the stuff that we've learned up to this point in the course in order to build it. So let's get started. Basically, this guessing game is going to allow the user to guess a secret number. So we're going to define a secret number, and we're going to give the user the opportunity to try and guess it. So if they'll try to guess it, if they get it right, then they'll win the game. And if they don't get it right, then we'll let them guess again, right? So we'll basically let them keep guessing what the secret number is until they get it. So down here, we want to create a couple variables. The first variable I want to create is going to be an integer, and it's going to be the secret number. So I'm just going to call it secret number, and why don't we just set it equal to 5? The next variable we want to create is going to store the user's guess. So this is also going to be an integer, and I'm just going to call it guess, and I'm not going to give it a value yet because right off the bat, the user wouldn't have guessed a number. So what we want to do is we want to be able to prompt the user to enter in the number until they get it right. So as long as the user hasn't entered in the correct number, we want to keep asking them to enter it in. In order to do that, in order to keep asking them to enter it until they've guessed it, we can use something called a while loop. So I'm just going to type while, and I'm going to make an open and close parentheses and an open and closed curly brackets. Let's think about a good condition for our game. Basically, we want to keep asking the user to enter an input as long as they haven't guessed the secret number. So it's right there. We could keep looping as long as the guess is not equal to the secret number, right? And basically, this is always going to be true until they guess the correct number. Now, inside of here, we want to prompt them to enter their guess, and then we want to take whatever they enter and store it inside of our guess variable. So let's do this first. We'll say printf, and I'm just going to say enter a number. And then down here, I'm going to use scanf in order to get whatever number they enter, and I'm going to store it inside of that guess variable. So I'm just going to say @guess. And this is going to take whatever number, whatever integer they enter, and it's going to store it inside of our guess variable. So basically what's happening in this loop is every time through the loop, we're getting a different number, and then we're going to come up here and we're going to check to see if it's equal to the secret number. If it's not, then we're going to go through again and we're going to keep doing this. But if the guess is equal to the secret number, then we'll break out of the loop, and that means we'll be down here. So I'm just going to print out a success message, and I'll basically just say hey, you win. All right, awesome. So you can see this isn't actually that many lines of code. I mean, it's probably 10 lines of code to write out this whole thing. And it looks like everything's set up, so this should actually work properly. So let's try to run this, and we'll see if we can guess the secret number. So remember, secret number is 5. So I'm going to run the program. It says enter a number. So let's just kind of botch the guesses. 2, 7, 8, 9, 3. So you'll notice I can keep entering in numbers, and it'll keep prompting me to enter a number as long as I haven't guessed it correctly. So now let's type in 5, and remember 5 is the secret number. And when I click enter now, that loop condition is going to end up being false, right? Because the guess is going to be equal to the secret number, and it's going to execute, and it's going to say, hey, you win, right? So we broke out of that loop. We executed the print statement that said you win, and the program terminated. And that is a really cool little game. So one of the cool things about this game, and it's different from programs that we've written in this course in the past, is it'll keep running essentially infinitely until we enter in that correct guess. So it's going to keep going and keep going and keep asking us to do something and to enter in a value until we entered correctly. So this is pretty cool. Now, this is a pretty nice game, and it's pretty simple, but I want to maybe make it a little more complex. One of the things that sucks about our game right now is that the user gets unlimited guesses, right? So basically, they can just guess every single number, and eventually they're going to get it right, So why don't we do this? We should impose a guess limit. So why don't we say the user can only guess 3 times, and if they can't get the secret number in 3 tries, then they'll lose the game. So let's think about how we can go ahead and add that functionality into this little app. I'm going to walk you guys through how we can do that. The first thing we're going to need to do is we're going to need to create some variables. I'm going to create another variable up here, and I'm just going to call it guess count. And guess count is basically going to tell us how many times the user has tried to guess the secret number. And I'm just going to set this equal to 0 because initially the user will have guessed 0 times. So remember, this guess count variable is basically going to get incremented every time they guess. right? So I'm gonna come down here. Every time we go through this loop, the user is guessing. So every time we go through this loop, I'm gonna increment the guess count. So I'm just gonna say guess count plus plus. And that means every time the user guesses, the guess count will get incremented and we'll have an accurate count of how many times the user has guessed. All right, the second variable that I wanna make is going to be another integer, and I'm just gonna call it guess limit. And this is gonna tell us how many times the user can guess. So this will basically determine like how many guesses the user gets. So why don't we set this equal to 3? I think 3 guesses is a pretty good limit. And finally, we want to create one more variable. And this is also going to be an integer. And I'm just going to call this out of guesses. And I'm going to set out of guesses equal to 0. And out of guesses will basically tell us whether or not the user has any more guesses. And this might not be super clear what this is doing right now, but keep following with the video and you'll see how this comes into play. This is actually gonna be really important. So we're actually gonna have to modify our code a little bit. So down here, we have this set up so the user can keep guessing as long as the guess isn't equal to the secret number. But we wanna be able to limit the amount of times that the user can guess. And actually down here, I'm gonna create an if statement. And every time we go through this loop, I wanna check and see if the user has any more guesses left. In other words, I want to see if they've reached their guess limit or not. So I'm going to make an if statement and I'm going to check to see if the guess count is less than the guess limit. As long as the guess count is less than the guess limit, that means they haven't guessed as many times as the limit specifies. Basically, they can guess again, right? So down here inside of this if statement, I'm going to put all of this code and I'm just going to surround this with curly brackets. So basically, the user can only guess the number. This code will only get executed when the guess count is less than the guess limit, when the user has additional guesses, right? When they haven't guessed as many times as the limit specifies. Otherwise though, so if they have guessed too many times, right? If the guess count is either equal to or greater than the guess limit, I'm actually gonna set this out of guesses variable equal to 1. So I'm gonna say out of guesses is equal to 1. And basically what this is gonna tell us is if out of guesses is greater than 0, then that'll tell us that the user is out of guesses. So essentially, if out of guesses has a value that's more than 0, we'll know that they've run out of guesses. And if you ever used any other programming languages before, this is what we would refer to as like a Boolean variable. It's basically storing like a true or a false value, which we're representing with 0 or 1. So if the guess count's less than the guess limit, they can guess again. Otherwise, we're gonna say out of guesses is equal to 1. In other words, we're gonna say that they're out of guesses. There's one more thing we have to do though, is we have to come up here and we have to change this condition. Because right now, we're gonna keep looping through this code as long as the guess is not equal to the secret number. But there's actually 2 situations where we want to break out of the loop. The first is when they've guessed the number correctly, right? Then we want to come down here and print out you win. But we also want to break out of the loop when they've run out of guesses. So I want to check to see whether or not they're out of guesses. So I'm going to say guess is not equal to secret number and out of guesses is equal to 0. So as long as out of guesses is equal to 0, that means that they're not out of guesses and they still have some guesses left. But if the guess count's less than the guess limit and out of guesses gets set equal to 1, then out of guesses isn't gonna be equal to 0 anymore, so we're gonna break out of the loop. So basically there's 2 scenarios now that will break us out of the loop. Either they get the word right or they run out of guesses. So one more thing we have to do in this program is come down here and you'll see down here we're always printing out you win. So no matter what happens, we're printing out you win. And that's because before, if they made it down here, if they made it out of that loop, that means that they guessed the secret number correctly. But there's actually 2 scenarios down here where they would have broken out of the loop, where they're either out of guesses or they guessed the secret word. So I want to actually check to see which one we're dealing with. So I'm going to check to see if out of guesses, and I'm going to check to see if it's equal to 1. And if it's equal to 1, that means that they lost and they ran out of guesses. So I'm just going to say out of guesses. Otherwise, though, it means that they won. So I'm going to say you win. And this will basically be like, hey, you won the game. Awesome. So this is a lot of code, I know that. And let's just run this, see how we did, and we'll see if our game's working properly, and then I'll kind of explain all the code to you guys. And actually, you know what? I just noticed a typo. Down here, I said out of guesses double equals 1. This is just have to be a single equals. So we're assigning this a value. So yeah, that was a little typo. I had 2 equals. That needs to be 1. So let's go over here. We'll run our program, and it says enter a number. So why don't we try to lose the game? I'm just going to say 2, 2. And now we're on our third and final guess. If I don't get it this time, that means we're going to lose the game. So I'm going to enter. And you'll see it says out of guesses. So we weren't able to guess it within our 3 tries, and the game told us that we lost. Let's run it one more time. We'll try to win. So I'll say like 2, 1. Now we're on our third and final guess. So if I don't get it this time, we're going to lose. I'm going to guess a 5, and we guessed right, so it's going to tell us that we won. So that's sort of basically how this little program works. And I'm going to walk you guys through one more time. So we have all of these variables up here. Secret number is just storing the number they need to guess. The guess keeps track of what they're guessing each time. The guess count is going to tell us how many times they've guessed the number. Guess limit is going to tell us how many times they can guess. And out of guesses is going to tell us whether or not the user is out of guesses. So down here, we're checking 2 conditions for this while loop. We're checking to see if the guess is not equal to the secret number. And we're going to keep looping as long as out of guesses is equal to 0. Every time we go through this loop, we check to see if the guess count is less than the guess limit. If it is, then we ask them to guess, we increment the guess count. Otherwise, we say out of guesses is equal to 1, and that's going to break us out of the loop. Down here, there's 2 situations. The first situation is that they ran out of guesses. The second situation is that they won the game, and we're using this if statement to check both of those. So that's basically how this works. And this kind of shows you how we can use things like while loops and if statements and also variables together in like one single program. In this tutorial, I'm going to teach you guys how to use for loops in C. Now, a for loop is a special type of loop that we can use in C, which allows us to use something called an indexing variable. And this indexing variable will basically tell us what iteration of the loop we're currently on. And we can use that indexing variable to do a bunch of stuff, like we could loop through an array of items. We could do all sorts of stuff inside of a loop. So down here in my program, you'll see that I have a while loop set up. And I have just sort of a basic while loop. And I want to show you guys what it's doing. So essentially up here I'm saying int I is equal to 1. So I'm giving this integer I the value of 1. And I'm saying while I is less than or equal to 5, I'm going to print out the value of I, and then I'm going to increment I. So this is a very simple while loop. Basically we have this variable I, and every time we go through the loop we're printing it out until it's greater than 5. So let's run this program and we'll see what it does. So you'll see over here, we're basically printing out values between 1 and 5. And I want to point out what's actually happening. So the first time that we go through this while loop, we're printing out 1. The second time, we're printing out 2. The third time, we're printing out 3. In other words, this variable I is basically telling us what iteration of the loop we're currently on. So on the first iteration of the loop, I is telling us that we're on the first iteration of the loop, right? The first time we go through the loop, I is equal to 1. Second time we go through the loop, I is equal to 2. Third time, I is equal to 3. So this variable I over here is basically telling us how many times we've gone through the loop. So on the third time, it's telling us 3, fourth time, 4, etc. And believe it or not, this is actually a very useful thing for us to have when we're looping. And so there's a lot of situations where you're going to want to know what iteration of the loop you're currently on when you're looping. So with a normal while loop, like I can basically just specify a condition up here and I can do whatever I want, right? It's very open. You can kind of just do whatever you want with it. But in a lot of situations, and there's tons of these situations, we're going to want to have a variable just like I that will tell us what iteration of the loop that we're currently on, or basically just a variable that's going to keep changing every time we go through the loop. And this is such a common situation in C that there's actually something called a for loop. And a for loop allows us to take all of this code and condense it into its own single loop. So it's taking this situation where we want to have a variable like I, and it's basically allowing us to do it a lot easier and a lot cleaner. So I'm going to show you guys how we can create a for loop. I'm going to come down here below this while loop, and I'm going to create a basic for loop structure. So I'm just going to say for, I'm going to make an open and closed parentheses and an open and closed curly bracket. Now, the difference between a for loop and a while loop is basically going to happen inside of these parentheses. So in the parentheses of a while loop, we have our loop condition or our loop guard, right? This is specifying whether or not we can keep looping through. Inside this for loop, we're going to have three different things. So instead of just one loop guard, we're actually going to have three different things that we want to put inside of here. So with a for loop, the first thing I'm going to put in here is this variable I. So you'll notice in the while loop, we have our variable I up here, and this is basically allowing us to loop through and keep track of how many times we've gone through the loop. So what I can do down here is I can do something similar. I could say like int I, and I'm not going to give this a value. Inside of here, I'm going to say I is equal to 1. So basically, I'm going to take my variable I, and I'm going to give it an initial value of 1. And now I have my I variable. I have my variable that's going to change every time we go through the loop. The next thing I want to do is include my looping condition. So up here we have I is less than or equal to 5. That's our condition. I can put the same thing down here. So I'm going to say I is less than or equal to 5. The third thing I want to do is increment I. So you'll notice down here, every time we go through this loop, we're incrementing that variable I. I'm going to do the same thing over here in this little third quadrant. So you'll notice I have these little like sections. Here's the first section. We're initializing the variable I. We're saying I is equal to 1. Here we're specifying our looping conditions. So I'm saying we're going to keep looping while I is less than or equal to 5. And over here is a little line of code that's going to get executed every time we go through the loop. So here I'm saying I++. I could also say like I minus minus, and that would decrement I. I could say like I is equal to I plus 2, etc. Like I could do basically anything I wanted over here. Let's just keep it at I++ for now. So you'll see I was basically able to take all of this code and condense it into its own little type of loop. And now instead of having to like print this out and create this variable up here, I can do all of that inside of this for loop. Now I could basically take this line of code, I could paste it down into here, and we essentially have the same thing. So right now, this block of code and this block of code are 100% equivalent. They're doing exactly the same thing. So let's go ahead and get rid of all this code, and let's test out our shiny new for loop. So I'm just going to run my program, and you'll see over here we're getting exactly the same thing that we got before. We're printing out 1, 2, 3, 4, 5. So it's the same exact program doing the same exact thing. And that's why for loops are great, because we can take that little structure like where we have an indexing variable and we can use it with something like this. So I want to show you another situation where these for loops can come in handy, and we can use them to loop through all of the elements inside of an array. So actually up here I have this array that I created. It's called lucky numbers, and I'm just going to grab this and bring it down here. So we have this lucky numbers array. It has 4, 8, 15, 16, 23, 42. And what I could actually do is I could loop through all of the elements inside of this array from this for loop. So I'm going to show you guys how we can do that. Now let's first off see how many elements we have. We have 1, 2, 3, 4, 5, 6. So we have 6 elements in this array. So what I'm going to do is I'm actually going to say I is equal to 0. And you'll see why we need to do this in a second, but basically array indexes start at 0. So this first element in the array is at index position 0. And just for a little refresher, if I wanted to access one of these elements from inside the array, I could say like lucky numbers was 0, and this is going to give me access to this element. If I said lucky numbers 2, then I'll get access to this element, this 15. So this is basically how we can access an element inside the array. So I'm going to set I equal to 0, and I'm going to say I want to loop while I is less than 6. And 6 was how many elements we had in the array. So I want to keep looping as long as we're less than 6, and I'm going to say I++. Now down here, I'm going to do this same exact thing, but instead of printing out I'm going to print out lucky numbers I. So I'm going to print out the array element at index position I in lucky numbers. Basically, the first time we go through this loop, we're going to be printing out lucky numbers 0. because I is going to be equal to 0. The second time we go through the loop, we're going to be printing out lucky numbers 1 because I is going to be equal to 1, etc. And we're going to keep doing that until we get all the way up to 5, which is going to be the last element, which is this 42. So let's go ahead and do that. So I need to put this back to I, and let's run this program. So you'll see over here, we're basically doing exactly what I said. So the first time through the loop, we're printing out 4. We're printing out that first element. The second time through the loop, we're printing out 8, which is the second element, 15, 16, 23, and 42. So we're printing out all of those elements in turn as we go through this for loop. And there's a lot of situations where for loops are gonna come in handy, but this is a very, 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 very common situation where we want to loop through all the elements in an array and either print them out or do something to them, whatever. So that's the basics of working with for loops. And I do just want to say, like, anything that you do with a for loop, you could do with a while loop. I basically showed you guys how we transformed that while loop into a for loop. The thing with for loops, though, is that they're very convenient. So it makes it really easy to do something like this without having to go through all the trouble of creating a while loop. In this tutorial, I'm going to talk to you guys about 2 topics in C. The first topic we're going to talk about are two-dimensional arrays. A two-dimensional array is basically a situation where we have an array where all of the elements in the array are actually arrays themselves. The second thing I want to talk to you guys about is nested loops. So we're going to look at how we can use a looping structure where we have a loop inside of a loop. So it's gonna be pretty cool. And actually these 2 topics can go together really well. And I'm gonna show you guys how we can use nested loops and two-dimensional arrays in order to make an awesome program. So let's get started. The first thing I wanna show you guys is two-dimensional arrays. So down here, we can create a 2D array. And actually the concepts that I'm showing you in this video can apply to multi-dimensional arrays. So not only 2 dimensions, but 3, 4, 5, really as many dimensions as your heart desires. So in order to create a two-dimensional array, I'm just gonna make an array of numbers. So I'm just gonna say int, and we'll give this a name. So why don't we just say nums? And normally when we create an array, after we'd say the name of the array, we'd make an open and closed square bracket. But when we create a two-dimensional array, we're gonna make 2 open and closed square brackets, just like that. These 2 open and closed square brackets will basically represent like the width and the height of our array. So you guys will see what I mean in a second, but basically we're gonna have like elements in the array, and then each of those elements is gonna be an array, and we'll have elements inside of it. So these 2 squares will allow us to like manipulate all that stuff. So what I'm gonna do is I'm gonna set this equal to an open and closed curly bracket. Now this is normally how we would create an array. So normally I would just say like 1, 2, 3, 4, whatever. I could put all my numbers in here. But with a two-dimensional array, all of the elements are gonna be arrays. So instead of just saying like 1, 2, 3, we're actually gonna create arrays inside of here. So for example, I'll put an array right here, and this text editor is so annoying with making these. So for example, the first element in this array, I could just make an array. So I'm gonna say this is like 1, 2. So you can see here, I have 2 elements inside of this array, which is itself the first element of the nums array. So let's make another one. I'm gonna come down here and we'll make another one, and this keeps trying to format differently. So now we're gonna say 3, 4. So this thing right here, this whole array, that's the first element in the nums array, right? And that array has 2 elements inside of it. Same thing with this one. This is the second element in the nums array, and it has 2 elements inside of it. So it's basically an array within an array. Let's make one more. And so this is gonna be 5, 6. So now we have 3 array elements, right? 1, 2, 3. And each of them has 2 elements inside of them. So whenever we create a two-dimensional array like this, we always have to specify the number of elements and then the number of elements inside each array. So in our case, we're gonna have 1, 2, 3 elements in the array, and each array has 2 elements inside of it. So it's gonna look like that. So we would say 3 and then 2. And that's basically how we create it. So now let's talk about accessing these elements. So I'm gonna create a little print statement here, and we're gonna print out some of this stuff. So I'm gonna say %d, and I'm gonna show you guys how we can access individual elements. So basically, I'm gonna say nums, and let's say that I wanted to access this top left element, this 1. The first thing I wanna do is specify the index where the value that I wanna access is stored. So like this would be index position 0, this would be index position 1, this would be index position 2. So we're gonna say 0. And then I want to specify the index position of the individual element inside of 0. So I could say like, this is element 0, this is element 1. So why don't we access element 0? So I print out nums 0, 0, and this is going to print out that number. It's going to print out that 1 for us. You can see over here we get that 1. So let's try a different one. Let's try to grab this 4 right here. So this is going to be at index position 1. And then 1. So this will be at 1, 1. And now we should get that 4. Let's see. Yeah, cool. So we get the 4. All right, so that's basically how we can access elements inside of these arrays. And I also just want to point out that if I didn't want to give this an initial value, I could just like put a semicolon here, and I could just like manually define each index location. So I could say like 0, 0 is equal to 7 or something. I don't have to give it a value like right up front. Although in our case, let's just do that because it's a lot easier. All right, so we have our nums array and we figured out how we can print out the elements. So now I want to talk to you guys about another concept, which is called a nested for loop. And you guys will see in a second why I'm teaching this alongside 2D arrays. But a nested for loop is a situation where we have a for loop, and inside of that for loop, we have another loop. So I'm going to show you guys this really quick. Let's say we create a for loop. I'm gonna create 2 variables over here, int I and int j. And I don't know if I've showed you guys this in the course yet, but if I wanna just like declare 2 variables, I can just say I, comma, j, and that'll declare both variables. Now, I'm not giving them actual values yet. We're gonna do that inside these for loops. So I wanna show you guys how we can use a nested for loop in order to print out all of the elements inside of this 2-dimensional array. So I'm gonna say for I is equal to 0, and we're going to keep looping as long as I is less than 3. And the reason I'm saying 3 here is because that's how many elements are inside of this nums array. So I'm going to keep looping as long as I is less than 3, and then I'm going to say I plus plus. Now, inside of these curly brackets, I want to create another loop. So every time we go through this one iteration of this top loop, we're going to fully execute through another loop. So I'm going to say for j is equal to 0, j is less than 2. And the reason I'm saying 2 here is because that's how many elements are inside each array inside of the nums array. And you guys will see in a second why this is going to work. And then I'm going to say j plus plus. So now I'm going to make some more open and close curly brackets. And down here, I'm going to actually be able to print out all of the elements inside of this array. So I'm going to go ahead and do that. I'm just going to say printf, and we're going to be printing out an integer because these are all integers, and we're going to be printing out nums. And I'm going to print out nums I and j. So whatever the value of I is and whatever the value of j is, that's the index position inside of nums that we're going to print out. And now just so this is formatted a little bit better, why don't we put a comma right there. And then I'm also going to put another printf over here. That's just going to print out a new line. And you'll notice that this printf is outside of this inner for loop. So I'm going to run this program. We're going to see what it does. You guys will see exactly what's happening, and then I'll sort of walk you through a little bit more what is going on. So let's run this program. And you'll see over here when we ran the program, we're basically getting this entire 2D array printed out. So I'm printed out 1, 2, 3, 4, 5, 6. So let's talk about why that happens. Over here, I'm saying for I is equal to 0, I is less than 3, I plus plus. So I'm going through this particular for loop 3 times. I'm going to execute all the code inside of this for loop right here 3 times. That's as many times as there are elements inside of our 2D array. Now, every single time I go through this top loop, every single time I go through it, I'm going to execute this loop in its entirety. So I will loop through this loop all the way through. I'll go through all of its iterations. And this loop says j is equal to 0, j is less than 2. And 2 over here is how many elements are inside of each one of these arrays. So this element in the nums array has 1, 2 elements inside of it. This element in the nums array has 1, 2 elements inside of it, right? That's where this 2 is coming from. Then I'm incrementing j, and I'm going to print out, so I'm saying printf, and I'm printing out nums at index position I and index position j. So the first time we go through this for loop, I is going to be equal to 0. And remember, that first time, we're actually going to be going through this loop 2 times. So we're going to be printing out nums 0, 0 and nums 0, 1. And then we're coming down here and printing a new line. The next time we go through this I loop, we're going to come down here and print nums 1, 0 and nums 1, 1. Finally, the third and final time, we're going to print out nums 2, 0 and nums 2, 1. That's basically how this is working. So two-dimensional arrays and nested for loops are a match made in heaven. And there's a lot of situations where, besides just looping through 2D arrays, that we're going to use nested loops. But hopefully this gives you a little bit of an introduction into what they are and why they're useful. In this tutorial, I'm going to talk to you guys about accessing memory addresses in C. Now, in the C programming language, a lot of times we're going to want to store different information, right? And there's a bunch of different ways that we can store information. We can use things like variables, we could use arrays, we could use structs. But the basic point is that whenever we're using C, we're going to want to keep track of and maintain a bunch of different pieces of information. And one of the easiest ways to do that is by creating variables. So down here, you'll notice that I have a bunch of variables. I have this integer called age, and it just has the value of 30. We have this double GPA, 3.4, and we have this character grade, and it has the value of the A character. I have a bunch of different variables in my program, and it allows me to keep track of data really easily, and I can use these to maintain, and I can even modify these different informations. Variables are great, but I want to talk to you guys a little bit about how these work in the actual physical memory of our computer. So whenever I create a variable, for example, when I create a variable called age and I give it a value of 30, this value 30 actually gets stored on our computer. So all computers have memory. So a lot of times you'll hear people refer to this as RAM. It's called random access memory. And basically RAM is the memory that your computer is going to use when it's running programs. So for example, if I was to run this C program, my computer would use RAM, it would use that memory in order to store and keep track of all this different information. Right? So when I create a variable like int age, C is actually going to store this value 30 at a specific memory location. So it's going to take that value 30 and it's going to store it somewhere in RAM, right? When I create this double called GPA, C is going to take this value 3.4 and it's going to store it inside of the physical memory on our computer. When I create this grade, C is going to store this character and the physical memory in our computer. Now, here's the thing. When I create these variables, I give them descriptive names, right? So I gave this a descriptive name, age, so I know what's stored inside of it, right? And when I want to access this value, I can just refer to the name, right? I can just refer to age. I could modify it. I could print it out. I could do something else to it, right? I can do whatever I want with it. And the way that I can access this variable, in other words, the way that I can access the value 30 is just by referring to the name of the variable. Same goes down here. If I wanted to access the grade, right? If I wanted to access this capital A, I could just refer to the name of the variable. But again, here's the thing. All of this information is stored in our physical memory somewhere. And so whenever C needs to access that information, whenever our computer needs to access this value 30 or this value 3.4, it's actually going to refer to a specific memory address, right? So when I want to access this variable age, I can just type out age and then I can use this variable. But when C wants to refer to this value, it's not actually using age, it's going to use the memory address where this value is stored inside of our physical memory. So all of these values are stored inside of a physical address in our memory. So all of these values have an address where they're stored in memory. And when C needs to access them, it can use that address. So I'm going to show you guys how we can access that address, how we can print out the address onto the screen, and basically just wanted to give you guys an introduction into what memory addresses were. So down here, I'm going to say printf, and I'm going to show you guys how I can actually print out the physical memory address where each one of these values is stored on our computer. So down here, if I want to print out a memory address, I need to use a % and a P. So normally if I was just going to print out like a number, I could say like %D, or I could say %C for a character. When we want to print out a physical memory address, we're going to say %P. And this actually stands for pointer. And we're not going to talk about pointers in this tutorial. We're just going to talk about memory addresses. But just know that you need to say %P. And now I'm going to type out the name of the variable whose memory I want to access. So I'm going to access the memory address of age. And before the variable, I'm just going to say ampersand. So I'm going to make an ampersand age, and I'm going to say %P. And now we should be able to print out the memory address where the variable age is stored. In other words, we can print out the memory address where this value 30 is stored. So let's go ahead and run our program. And you'll see over here, we're getting this number. So I'm getting this number 0060FF00. So this would be like a hexadecimal number. I guess it's not technically a number. It's like, I think it's hexadecimals. But basically, this is the physical memory address where the value of 30 is stored. In other words, it's the place where C stored the value inside of this age variable. I could do the same thing for these other variables. So actually, why don't I format this a little bit? I'm gonna say here age, and then I'm gonna make a new line, and we're just gonna say GPA. And again, I'm gonna print out another one of these addresses, and we'll do one for grade, and we'll print out the address. So now I can just come over here and I can sort of modify this a little bit. So I can just say GPA and grade. And you'll notice for each of these, I'm using this ampersand before I type out the name of the variable. So now when we run our program, we should get a nice little list of all of these variables and their corresponding addresses. So you'll see over here, we have age, and it's stored at memory address 0060FFOC. GPA is stored at this memory address, and grade is stored at this memory address. So if you were to like go into our computer or go into my computer and go to memory address 0060FF0C, that's actually going to store the value of 30. It's going to store the value that's inside of that age variable. If you were to go to this memory address, you would see the value inside of GPA. If you were going to this memory address, you would see the letter, which was a capital A. So basically, all of these variables are stored at different memory addresses. When I want to access the information in the variable, I can just refer to the variable's name. So I could say age, or I could say GPA. But when C wants to access the information in the variable, it has to use these addresses. So C would use this address, C would use this address, and this address. I can just use the variable names, and that's why C is awesome, because it allows us to do stuff like that. But when C and when our computer wants to access these values, it has to use these memory addresses. And so that's why these are useful. And when we're programming in C, it can actually be pretty useful to be able to know the addresses, like the actual physical addresses of these certain variables in memory. So a lot of times in C, when we want to work with these variables, we can just refer to them by name, and we can do all sorts of stuff with them. We can access them, we can modify them. But in other circumstances, we're not just going to want to be able to access the value, we're also going to want to be able to access their physical memory address. In other words, we're going to want to be able to know like what that address is, and we can use that for a bunch of stuff. And in future tutorials, I'm going to talk about why that can be useful. But for now, I really just wanted to kind of give you guys an overview of what memory addresses are, how we're using them in our program, and how we can print them out. So again, I just use this ampersand, and then I type the name of the variable, and I use this %P to print it out. In this tutorial, I want to talk to you guys about pointers in C. Now, a pointer is basically just a type of data that we can use inside of our programs. So up until this point in the course, we've been using a bunch of different types of data, right? We've been using things like integers, and an integer is just a whole number. We've been using things like doubles, and a double is a decimal number. We've been using chars, and a char is basically just a character. And now I want to introduce you guys to another type of data, which is called a pointer. And a pointer is basically just a memory address. And a memory address basically refers to a physical address inside of the memory of our computer where we're storing a value, right? And I think pointers tend to confuse a lot of people who learn about them. And this is sort of one of those topics in C that everybody dreads because it's, traditionally very confusing to understand. But actually pointers are extremely simple. And the problem is that they just get overcomplicated. So what I want you guys to do is I just want you guys to think of a pointer as a type of data. That's all it is. It's just a type of data that we can work with in our programs. It doesn't have to be any more complicated than that, right? I can work with an integer in my program. An integer is a whole number, right? I can work with a double in my program. A double is a decimal number. I can work with a char in my program. A char is just a character. I can work with a pointer in my program. A pointer is just a memory address. That's it. A pointer is just another type of data that I can use and I can work with inside of my programs. And it just happens to be a memory address inside of the memory or the RAM in our computers. That's all it is. It's very simple. People overcomplicate pointers and they don't have to be overcomplicated because it's just another type of data, just like an integer or a double. But instead of being like a whole number or a decimal number, it's a memory address. So hopefully that makes sense. And I hope that you guys don't try to overcomplicate this too much because it doesn't have to be. So down here in my program, I have an integer that I've created and it's called age. So I just said int age. And inside of this integer age, I'm storing a whole number. I'm storing an integer, right? 30. And if you've been following along with this course, in the last tutorial, we talked about memory addresses. And we talked about how all of these variables are actually storing these values at physical addresses on our computer's memory. So down here, I have this print statement, and I'm just printing out age's memory address. And I'm using this %p, and I'm just printing out ampersand age. And we talked about how this ampersand, when I put this in front of the variable, basically it's going to give me the physical address in memory where this variable, in other words, where this 30 value is stored. So if I run this program, you guys will see over here it says age's memory address, and it's this hexadecimal number, right? This is the physical memory address of the age variable. What did we just talk about before? Remember what I told you? Pointers are memory addresses. That's what they are. It's a type of data. A pointer is a type of data in our program, and it's a memory address, right? When I use this ampersand and I type out the name of a variable, this is giving me the memory address, right? I'm able to print out the memory address. So really, this is a pointer. This is a type of data in our program that is a memory address. Just like an integer is a type of data that's a whole number, and a double is a type of data that's a decimal number, and a char is a type of data that's a character, a pointer is a type of data that's a memory address. And this right here, this guy right here is a pointer. So it's just the memory address of the age variable. That's it. And when I want to print out a pointer, I can use this %p, and it'll allow me to print it out onto the screen and everyone's happy. So essentially what I'm doing here is I'm printing out a pointer. When I say %p, I'm telling this printf function that I want to print out a pointer, and then I give it a pointer over here. I give it a physical memory address. That's what a pointer is. Now we understand, and hopefully you understand, that a pointer is just a type of data, right? It's just a memory address. And we can access the memory addresses of specific variables by using this ampersand and then typing out the name of the variable. And that can be pretty useful. Now that we understand that, I want to show you guys how we can work with these pointers. So over here, I have an integer variable called age. And this integer variable is storing an integer value 30. I'm going to say that one more time. I have an integer variable, and this integer variable is storing an integer value 30. I could also create a double variable. So I could create a double called GPA, and inside of this double variable, I could store a double value like 3.4. I could also create a char variable called grade, and inside of this char variable, I could store a character, A. I could also create a pointer variable. And inside of that pointer variable, I could store a pointer, okay? So just like I stored a character inside of this character variable and I stored a double inside of this double variable, I could store a pointer inside of a pointer variable. So we can actually store these pointers inside of a pointer variable. Now, here's where this is going to get a little bit tricky. When we create a pointer variable, we actually need a physical memory address, right? So when I create this integer variable, like I can just come up with a number right off the top of my head, right? I can just say like 30. When I create a double variable, I can just store whatever number I want to store. But when we create a pointer variable, remember, we're going to be storing a memory address. And I don't necessarily know any memory addresses like right off the top of my head. At least I don't know any meaningful memory addresses. So when I create a pointer variable, what I want to do is store the memory address of a variable that's already in our program. So I'm going to say that one more time. When I'm creating a pointer variable, inside of that pointer variable, I'm going to store the memory address of another variable inside of our program. So let's say that I wanted to create a pointer that would store the memory address of this variable over here. So store the memory address of age, right? I can create a pointer just like this. So I could say int, an asterisk, and now I'm going to give this a name. So I'm going to give this pointer variable a name. And remember, this pointer variable is going to store the memory address of the age variable. And generally, when you're naming a pointer, you're going to start with a lowercase p, and then you're going to type the name of the variable whose memory address you're storing in the pointer variable. So I'm going to say page, right? Because this pointer variable is storing the physical memory address of the age variable. Now what I want to do is set this equal to the memory address of the age variable, which we can access using this ampersand. So I could say ampersand age. So now this pointer variable is storing the memory address of the age variable. I'm going to do the same thing down here for this GPA. So if I wanted to create a pointer variable that would store the memory address of the GPA variable, I could say double asterisk, and I'm just going to say pGPA, just like that. And I'm going to set this equal to the memory address of this double variable, which we can access using this ampersand and then the name of the variable like that. I'm going to do the same thing down here for this character variable. So I want to create a pointer variable, which is going to store the memory address of the character variable. So I'm just going to say char asterisk a grade, and I'm going to set this equal to ampersand grade. Okay, so that's all I'm doing, right? So now I have this integer variable, and I have this pointer variable, which is storing the memory location or the memory address of the age variable. I have this double variable, which is storing a double, and I have this pointer variable, which is storing a pointer, and the pointer just happens to be the memory address of the GPA variable. I have this char variable down here, and then I have this pointer variable, which is storing a pointer, which just happens to be the physical memory address of the grade variable in our memory, okay? And that's basically all you need to know about pointers to get started. A pointer is just a type of data. It's just a type of information that we can work with in our programs. It just happens to be memory addresses, right? An integer is a type of data that we can work with in our programs, and it just happens to be a whole number. A double is a type of data that we can work with in our programs, and it's a decimal number. A char is a type of data that we can work with in our programs, and it's a character. A pointer is a type of data that we can work with in our programs, and it's a memory address. Hopefully that makes sense. And just like we create integer variables and double variables, we can also create pointer variables. The only difference is whenever we create a pointer variable, we're going to store the memory address of another variable in our program. So you'll see over here, when I create this pointer variable, I'm using the data type of the variable whose address I'm storing. So over here, when I'm storing the address of an integer variable, I'm saying int here. When I'm storing the address of a double variable, I'm saying double here. When I'm storing the address of a char variable, I'm saying char here. And that's the basics of using pointers and also creating pointer variables and storing memory addresses inside of variables. In this tutorial, I want to talk to you guys about dereferencing pointers in C. Now, a pointer is basically just a type of data that we can work with in our programs that is a memory address. So sometimes in our programs, we're going to want to work with memory addresses. We're going to want to use them in our programs and do certain things with them. And those memory addresses are basically called pointers in our programs. And when you dereference a pointer, essentially what you're doing is you're going to the memory address of that pointer and you're grabbing the piece of information from there, right? So all pointers are memory addresses. And when we dereference a pointer, we go to that physical memory address and we get the information, or we get the value that's stored inside of there. So I'm going to show you guys how we can do that in C. It's actually really easy and can be pretty useful. So down here I have this integer, and it's an integer variable, and it's storing the integer value 30. And over here I have a pointer variable, which is storing the memory address of 30. So it's storing the memory address of our age variable, as you can see right here. And down here I'm just printing out this pointer. So I'm printing out page, I'm using this %p, and I'm just printing it out to the screen. So why don't we take a look and see what we get. So you'll see over here, we just get this memory address, probably exactly what you expected to get. So over here, I want to show you guys how we can dereference a pointer. So this pointer variable page is storing the memory address of this age variable, right? So when we printed it out, we basically were given the physical memory address where this number 30 was stored. So page is storing the memory address of 30. It's storing the memory address where this value is inside of our computer's memory. If I want to dereference a pointer, basically what I'm going to be doing is I'm going to be going to that actual physical memory address and grabbing that piece of information. So the way that I can dereference a pointer is by using the asterisk. So when I'm printing this pointer out, I can dereference it by using this asterisk. But now over here, since I'm dereferencing this pointer, I need to print out a number instead of a pointer. Because when I dereference the pointer, this is no longer a pointer. This is no longer a memory address. Now, this is going to be whatever was stored at the memory address the pointer was pointing to. So this is going to be an integer because this pointer variable was storing the address of an integer, right? So when I dereference it, this is actually going to be an integer. So let me show you guys. I'm going to print out, or I'm going to run our program, and it should print out 30. So you'll see there we get a 30. So basically what's happening here is we're dereferencing the page pointer variable. We're dereferencing the page pointer, which basically means we're going and grabbing the actual, physical value that's stored at the memory address that the pointer was pointing to. And that's why we get 30. And that's basically what dereferencing is. You have a pointer, you can dereference it, and you basically just get the value that it was pointing to. It's essentially all we're doing. So I want to show you guys how we could do this just normally. So for example, I have this age variable. If I just typed this out, if I wanted to get the address of this age variable, I could use this ampersand, right? That's basically what we did up here. But what I could do is I could just dereference this. So I can say ampersand age, and then I can put a asterisk here, and this is actually gonna dereference that entire thing. So now when I run my program, it's going to print out 30. So it's not going to print out the memory address, it's just going to print out 30. So you can see over here, we get 30. So I could actually do this like as many times as I want, and this will maybe just illustrate what's happening. So I could put an ampersand here, and now I'm going to get that memory address again. So you'll see we're getting this memory address, and I could do the same thing. So I could dereference this one more time. And you'll see now we're getting that 30 value again. So, I mean, basically what I'm doing here is I'm constantly like here I'm getting the memory address where the age variable is stored. Then I'm dereferencing it and getting the value. Then I'm getting the memory address again, and then I'm dereferencing it again. So Hopefully that makes sense. When you dereference a pointer, you're basically just getting the value that that pointer is pointing to, or you're getting the value that's stored in the memory address of the pointer. In this tutorial, I'm going to teach you guys how to write to files in C. One of the cool things we can do in C is we can actually modify and change and also create new files. So in this tutorial, I'll just basically show you guys how to do that. We'll talk about creating files, writing files, and appending onto files. So let's go ahead and do that. Down here in my main function, we're actually going to create a file. So I'm going to create a file and I'm going to store some information inside of that file. And the way that we can do that is we can just type out file all in caps, just like that. And essentially what we're doing here is we're creating a pointer to a physical file on our machine. So I'm just going to say file, and I'm going to make an asterisk, and I'm just going to give this a name. So I'm just going to call this F pointer, and that'll just stand for file pointer. And I want to set this equal to F open. And F open is actually a function that's going to open a file for us. And so inside of these parentheses, I'm going to give this a couple different parameters. The first parameter is going to be the name of the file that I want to open. So I'm just going to call this employees.txt. And the second parameter is going to be a file mode. And a file mode is basically just going to tell C what we want to do with the file that we're going to open. And there's a bunch of different file modes. The three most basic types are R, and R stands for read. So if I put R in there, it'll mean we want to read the file. W stands for write. So if I put write in there, it means I want to either create a new file or write over an existing file. And there's also A, which stands for append. And that means I want to append information on the file. In this tutorial, we're going to look at W and A. So what I want to do over here is put in W. And right now, employees.txt, this file doesn't actually exist. So what I'm going to do is I'm actually going to create that file. We're going to put some information inside that file, and then that file gets saved onto my machine. And in order to do that, we're going to need this write mode. So it's just going to be a W. Anytime that we're opening a file in C, you always want to make sure that you close the file. So over here, I'm saying fopen. And down here, I want to use another function called fclose. And basically what this is going to do is it's going to close off the file. So it's going to remove the file from the memory on our computer. And if we do make any changes, it'll kind of like save the file and everything will just be kind of like locked in. So you always want to make sure whenever you're working with a file that you close it. And inside of this fclose function, we just want to pass in this f pointer. So I'm just going to say f pointer right there. So let's talk about what's happening here. File is basically just like essentially like a data type, I guess, and we're creating a pointer to a physical file on our computer. So if you remember, a pointer is basically just a memory address, right? A pointer is a type of data that we can use in our programs. It's essentially just a memory address. And this pointer is storing the memory address of this new employees.txt file that we're going to create. So essentially what's going to happen is we're going to create this employees.txt file, and f pointer is going to be pointing to the memory address of that file on our computer. So that's essentially what's happening here. And what I want to do is I actually want to write some information to this file. So actually, let me just show you guys really quick what's happening here. So without doing anything else, just using this line right here, when I run my program, a new file called employees.txt is going to get created. So over here, I'm in my little directory, and if you don't specify an absolute path or like a relative path for this, it's just going to create it in the directory that your C file's in. So if I wanted to create this on my C drive, I could say like C whatever, and then like employees.txt, and this will get created in my C drive. But if I don't specify like an absolute path, or even if I don't specify a relative path, then this is just going to get created in the same directory as our C file. And you'll see over here, my main.c file is right here. It's in this folder. So when I run this program, let's watch over here and we can see this employees.txt file get created. So I'm going to run my program, and you'll see over here that this employees file got created. So if I actually bring this out a little bit, you'll see it's a text document. it's employees.txt, and there's 0 kilobytes inside of there. So we haven't put any information in there, but this file got created. So now let's talk about putting some info into that file. Inside this file, I'm basically just going to list out a bunch of like employees that might work in an office. And the easiest way to write information to a file is just to say fprintf. And this is a special function in C, which actually works a lot like the printf function. So if you've used the printf function, and if you're following along with this course, we've been using it throughout the entire course. The printf function basically allows you to like print information out onto that console window. Fprintf is going to allow us to essentially just write information to a file. I need to give this a couple parameters. The first one is going to be this file pointer. In other words, I need to tell this function, what it should be writing to. So I'm just going to say fpointer. And then over here, we can just give this some information. So I can just use, like after we put in this file pointer, I can just use this like I normally would the printf function. So I could just print out like some employees. So I could say like, let's say one of the employees is Jim, and we'll put like what they do. So like I could say salesman, and then we could say, actually let's make a new line, and we'll create another employee, Pam, and she is the receptionist. And then we can make some other employees. So now I have 3 employees that I'm going to basically write out to my employees file. So now when I run this program, and we can go over here to this employees file, you'll see when I open this up that we have these 3 lines in here. So we have Jim salesman, Pam receptionist, and Oscar accounting. So basically I was able to create this file and write all of this information in the file from down here, just from down here in this program. So that's pretty cool. And I want to show you guys with write. So when I'm using this write, this is actually going to overwrite a file. So for example, if I change this from all this text and I just put like overridden in here, now when I run this program and we open this employees.txt file, so let me reopen this, you'll see it just says overridden. So I've actually overridden all of the text that was in there. And that's basically what happens when we just write to a file. So let's go back to what we had before. I'm just going to run this again. So we have this text. And you'll see now we're back with the employees. So let's say that inside of this file, we wanted to add an employee onto the end of it. So we wanted to add like a new employee onto this file, right? Well, I can use something called append. And what append is going to do is it's going to allow us to append a new line onto the end of this file, or actually just append text onto the end of the file. Instead of saying W, I'm just going to say A, and you'll notice I'm still keeping employees.txt here. And down here inside of this fprintf, I'm just going to print out another employee into the file. The first thing I'm going to do is print out a new line because, and actually let me show you guys this in this employees file, there actually isn't a line after this last line. So the last like position in this file is over here. I can't actually get onto the line below Oscar. So I'm gonna want to go ahead and print a new line, and this will move the next employee onto the next line. And we could say like Kelly, and she's gonna work in customer service. So now when I run my program, instead of overriding what was in the employees.txt file, now this is just gonna append this new employee onto the file. So I'll come up here, run the program, and let's open this employees file, and you'll see now we have another entry, Kelly from customer service. So when we write a file, we either create a new file and add content onto it, or we just overwrite the content in the file, at least using this fprintf function. And when we append, we're just appending information onto the end of the file. So just using those 2 things, I mean, you can essentially write out any file that you want. And it's important to note that you can write more than just text files. So I could write like an HTML file, or I could write like a CSS file. You could write really, I mean, any type of file that you'd want. And that's basically how we can write to a file and append to the end of a file. In this tutorial, I want to teach you guys how to read the information from a file in C. In the last tutorial, we talked about writing to files. So we looked at how we could create a file, overwrite a file, and append information onto a file. In this tutorial, I'm going to show you guys how you can read information from a file. So down here, you'll notice that I have my file pointer set up. So I just say file, and the asterisk, and I called it FP. And remember, this is just a pointer, which, and a pointer is just a memory address. And it's the memory address of this file in memory. So it's the memory address of this employees.txt file, which we created in the last tutorial. And I'm using this fopen function, which basically opens this file, and then I'm specifying a file mode. We talked about the W file mode and the A file mode. Now I want to talk to you guys about the R file mode, and this stands for read. So when I use the R file mode, I'm actually able to read information from the file, and this can be pretty cool. So in order to read the information from the file, I'm actually going to show you guys how we can read like the individual lines of the file. So actually first let's look at the file. This is employees.txt. It just has basically a bunch of employees, their names, and then what they do. And we're going to be able to read this file inside of our program. So the first thing I want to do is create a variable. And I'm going to create this variable up here before we create the file pointer. And it's just going to be an array of characters, and I'm just going to call it line. And I'm going to give this an initial size of 255. So this will be able to store 255 characters. And then down here, in order to read this file, I can actually read the file one line at a time. And we can use a special function called fgets. And fgets basically is going to allow us to read the lines of the file one by one. So I could say fgets, and I need to give this a few different parameters. The first parameter I need to give it is a place to store the information that it gets. So this function is going to go and it's going to read the information from the file, and it's going to store it somewhere. So the first parameter we need to give this function is where it should store that information. So in our case, we're going to store it inside of that line variable that we created up there. The second thing we need to give this is a size. And this is basically just going to be like the maximum size that we can read in. So I'm just going to say 255. Basically, this number should match this number up here. And then we also want to give it that file pointer. So I'm just going to say f pointer. And basically what this is going to do is it's going to read the first line of the file, and it's going to store it inside of this line variable. So if I was to come down here and say printf and printed out a string and just print out line, now when I print out line, it's actually going to have the value of the first line in the file. So let's run this program, and you'll see over here we're printing out Jim salesman. And if you don't remember, that was the first line inside of that employees.txt. So basically what fgets is doing is it's reading the first line, and another thing that it's doing is it's moving this pointer. So remember, this pointer is essentially pointing to where the file is in our memory. And whenever we use fgets, this pointer is going to get incremented. So it's basically going to move past the first line in the file. So if I was to use this again, for example, if I said fgets again, when I use this, it's going to store the value of the first line of the file inside of line. And when I use it again, it's now going to grab the second line in the file. So if I print this out now, this should actually be storing the second line in the file. So when I run my program, you'll see it's storing the second line, Pam receptionist. I could basically do this for all of the lines in the file. So that's basically how we can use fgets to read the individual lines inside of a file.